commerce. So where we discussed about what is meant by traditional commerce, what is meant by e-commerce, what are all the differences between traditional commerce and e-commerce, different e-market model, different business models, and advantages to various stakeholders like business, customer, or government. And also we discussed on components of e-commerce. So there are 6 components in e-commerce, like user, e-commerce vendor, the network, web portal. And we also discussed in detail about e-commerce vendor and the technology infra part. On the architecture of networked systems, we discussed about 2-tier architecture and 3-tier architecture. What are all the advantages and disadvantages of architectures? So workflow diagram is simple, the sequence of steps you follow when you're doing a transaction on e-commerce platform. And when come to risks and related to e-commerce, we talked about different kind of risks in e-business environment, what kind of controls you can implement. And also on the cyber security risk considerations, we talked about different the things which are having direct financial impact. Some of the risks doesn't have a financial impact, but it have an impact on operational side, like loss of customer data, goodwill, those kind of the examples. And we then we moved on to guidelines and laws governing e-commerce, where we talked about couple of guidelines to be followed by e-commerce vendors, like having detailed policies for shipping, returns, the products, and also commercial laws. So there are some 10 or 11 laws that are applicable to the e-commerce entities. Under special laws, we talked about Information Technology Act. There are certain provisions which have given a validity to the transactions which have been done electronically, and also if you are storing the data electronically. So for these kind of transactions, IT Act has given a validity to those activities. And forces behind e-commerce, we just saw a couple of forces that helped the e-commerce business to grow. And then we moved on to the types of digital payments, where we talked about the traditional versus new digital payments. And especially we talked about UPI app, mobile app, AEPS, USSD, cryptocurrency, e-rupee, like that, and the advantages and disadvantages of digital payments. Then we entered into the most important topics in chapter number 4 under computing technologies, where we discussed about virtualization. So there are 3 types of virtualization: hardware, network, storage virtualization. And then we moved on to grid computing. We understand what is meant by grid computing, and there are what kind of resources that are being shared under grid computing, and application areas in practical scenarios, which are all the areas where this grid computing can be utilized, and also certain security considerations that need to be taken care if somebody is implementing grid computing. And we entered into cloud computing, where we had an initial understanding of what is meant by cloud computing, what are all the different characteristics, advantages, and drawbacks. So especially we are talking about cloud computing environment. This is where we stopped: the private cloud, public cloud, hybrid, and community cloud. In today's chapter, we will continue this cloud computing. We will start from continuing the cloud computing, and we will cover the rest of the topics. So as today is the last day for chapter number 4, we will be covering all these topics, and we will also see a couple of past examination related question papers, and any doubts, be it on concepts or even on the multiple choice questions, which I have given for you to practice. So feel free to ask any doubts, students. So this is what the plan for the day. Let me see on the chat window. I think it got stuck. Okay. Let me re-log in. There is, I think, some issue in the page. Technical team, can you please check? I'm unable to check the chat box, the question answers screen. Before start, yeah. The chat box I'm not able to see, Ramji. Okay. Students, No worries. In meantime, the technical team will check for the chat box. I might not be able to see your queries, but let's get started from the cloud computing part. And once the page is loaded, I can check all your queries, and if there are any, we can discuss. So I'm starting from the cloud computing. Just recap the definition, what is meant by cloud computing. So this is more important, and especially from examination point of view, students, cloud computing is one of the very important topic. Couple of times there are multiple questions on this. Okay, so please make sure you understand the concept and follow the explanation. Cloud computing means the use of computing resources. Whenever you use this plural term, resources, that means there are a couple of things related to computer we are using. What are they? We will understand. As a service, okay? This is the first important term in the definition. The second thing, as a service through networks, typically the internet. So if you understand these three terms, then you understand what is meant by cloud computing. So as a service, you are utilizing certain computing resources, okay? That resources can be hardware as well as software in a very broader term, okay? Then when we get into the cloud computing service model, like SaaS, software as a service, infrastructure as a service, platform as a service, then you will understand the actual definition of computing resources. For now, just understand you are using certain hardware or a software as a service via internet. So this is called cloud computing. Now I could able to see the chat box. Fine. It's getting loaded. Let's move on from the definition here. Yeah. So there are 4 types of cloud computing environments. Students, as I said on last class, remember there are 2 topics in cloud computing. One, we talk about environments. The second thing is cloud computing service models. Okay. Where we talk about what is infrastructure as a service, platform as a service, software as a service. So when you got a question in examination, you should be very clear about this terminology, whether they asked about the cloud computing environments or service models. Okay. So the first one is private cloud. First, let me read to the terms: public cloud, community cloud, and hybrid cloud. These are very simple to understand. Let me go through what is meant by private cloud. See, we are talking about in the organization context. If you see this diagram, students, there is an organization. Okay. First and foremost, you remember the example of Google Drive or a Gmail application where you are utilizing that service, but none of them are from your local machine, right? Your access. For me, it's not loading, Ramji. I'm getting a blank page. Okay, let me do it. Yeah, thank you. 1 minute, student. Let me open in another browser or else. Yeah. So if you see in this organization, visualize they are using some software or some storage space for the entire employees in the organization. They want to give that facility. So what they have done in that organization premises, in their same premises, they have kept that server here. Where is the server? In the central or head office of the organization. And there are a lot of employees in the organization who work from different locations. Okay. But they all can access this server because they all belong to the same organization. Nowadays, as I'm working for one of the MNC, lot of like applications I access by sitting at my home. Okay. How is that possible? They hosted it on the cloud. So this is called private cloud. Means who all can access this? Only the employees of the organization within that, like who are from that organization. Example, your friend is there who is not working in that organization. He cannot access either that software or hardware. Okay. Now let us see the definition. This cloud computing environment resides. Residing means stays. Where it exactly stays? Within the boundaries of organization and is used exclusively for organization benefit. So that access to that software or a hardware resource will not be given to any person who is outside of the organization. So that will be used for the people or by the employees who are form part of that organization. So that's called private cloud. So there are few more names with which it will be called. It's called internal cloud because they are within the boundaries of the organization, or corporate cloud. So remember these synonyms as well. Sometimes in the examination, see, you might be read private and public very easily. You can remember if they have used internal or a corporate cloud, you should still be able to refer private cloud. Okay. Just a minute, students. Technical team, I'm still not able to access the chart page on my machine. I logged in with another browser as well. I'm able to log in, but once I log in, it is giving a blank page. Ramji, can you please check once on this chat box? Okay. In meantime, let us continue. Once that is up and running, I'll be able to see your queries, anything. So I hope you understand what is meant by a private cloud. In simple terms, it's a cloud. Okay. When I say cloud, you're using certain resources as a service. So in the organization perspective, let's say you are using an ERP application. Okay. That application is installed within the boundaries of the organization, and all the employees within the organization can access that application. Nobody else outside of that organization can access it. Or organization using similar to Google Drive or a OneDrive, they might be having some shared folders. So where all the documents relating to the organization are placed. So you or me, if we are part of that organization, we can access it. But anybody who is outside of that organization will not be given access. So this is purely like who will be setting up this cloud environment? That organization itself. If that software requires any hardware, where it is installed? On the organization computer hardware itself. So the software is also residing in the organization and the hardware also residing in the organization premises only. So both hardware and software are owned and managed by the organization. So this is the most important takeaway. So both the hardware and software related to that application or service are owned and managed by the organization. Give me a minute, students. Then next, first let me complete the different kinds of environments, then you'll be able to understand much. And when we get into the cloud computing service models, you should combine these two topics to understand the real meaning of cloud computing. Now, just the opposite of public cloud, private cloud is a public cloud. What is meant by public cloud? Before I discuss about the definition, public cloud, when we discussed about Gmail, all these are the examples of public cloud. Gmail application, or let's say Google Drive, OneDrive, even the DigiLocker, all these are examples of public clouds where the common public can access that service. Now, my question is, if you remember our examples in private cloud, Google Drive, anybody can access it, right? Or even for that matter, Gmail, anybody can create an account with Gmail and can start using their email IDs. It doesn't necessarily mean that all are from the one single organization. So basically, public clouds are used by common public. If you see here, the public cloud is the cloud infrastructure, okay, that is provisioned for open use by the general public. So predominantly, who use the public cloud related softwares or hardwares? By general public. So these are administered by third parties or vendors over the internet. Example, if you see Google Drive, who manages it? Google. OneDrive managed by Microsoft. DigiLocker by Government of India. Like this, there are some third parties or vendors who manages these applications or services, and these are offered on pay per use. So basically you need to pay it out. So as we discussed a couple of times in our previous sessions, basically they will give some free 10 GB, 50 GB capacity. And then if you want to use beyond the storage capacity, then you have to pay as per your requirement. So these are also called provider clouds. So there is another name for public cloud, provider clouds. So users can simply, multiple people can access the public cloud. So even an example, this organization can also use Google Drive for their official purposes. So even customer B can also approach, example, this is managed by Google, right? So any of the company can approach Google and take the services of Google Drive and use it for their business purposes. So this is what public cloud. Students, I'm still not able to see the chart queries. So for now, let me continue. We can't hold the class. Meanwhile, the technical team will be looking into it. I hope you understand the private and public cloud. But in the public cloud, who is maintaining the hardware and software? When we are using Google Drive, are we maintaining the hardware? Especially Google Drive is used to store your documents. So where the documents will be stored? On the server, right? So are you maintaining that server? No. Are you buying that server? No. Are you maintaining that software, Google Drive software? No. Are you maintaining? So you are not spending either to buy or to maintain that hardware or a software. All you're doing was paying a rent, okay, and then utilizing it. Something like if you buy a car, that is buying a car. Whereas on renting a car, you just pay the rental. The car related maintenance will be taken care by the car service provider. Similarly, on public cloud also, when you are taking any services of these products, could be software or a hardware, all you pay is a rent to the service provider. You don't bother about the initial capital expenditure nor the periodical maintenance expenditure. You are not concerned about it. So this is about public cloud. Now, the next one is hybrid cloud. Hybrid cloud means you have a combination of at least one private cloud and public cloud in your organization. This is called public cloud. So as you see in the diagram, it has a combination of public cloud and private cloud. If you see here, public cloud from the security perspective, anyway, we will discuss when we are talking about characteristics. All I'm doing now is introducing this terminology, and then on top of it we'll be further discussing what is meant by each of these cloud environments, how they are different from one another, what are all the advantages and disadvantages we will discuss. So if you see, it's a combination of both the private and public cloud computing is called hybrid cloud computing. So we will come to know why the requirement of hybrid cloud comes into picture. But for now, just understand the definition, what the organization, how they will be using it. Any non-critical activities they will be performing on the public cloud. Any critical activities for the organization, they are using private cloud. So it has an option given to the businesses to use hybrid cloud environments as well. Now the next one is community cloud. Community cloud means where multiple organizations will be there. Let's say there is one more organization called organization 4. This will not be given access to this community cloud because this is owned and managed by only organization 1, 2, 3. Only those 3 organizations came together. Maybe they all working on a common project. And due to that, they are using a cloud services for their 3 organizations only. None of the people from outside of those 3 organizations can be able to see this community cloud. So in this example, if any employee from organization 4 cannot access the services of community cloud. So if you see here, the cloud infrastructure that is provisioned for exclusive use by a specific community of consumers from the organizations that have shared concerns. So whoever are working on a, maybe all those organizations are working on a common project. So then only those organizations can use that cloud computing services. So who owned or managed? So it can, who owned and managed, either it can be one of the organization or all these three organizations together can manage. Sometimes they can give the maintenance part to an outside service provider. Example, something like Google or a Microsoft, they can give the maintenance to some other. But who only can use this community cloud? Only these three organizations. Anybody from other than these three cannot use the services of community cloud. So these are the different 4 cloud computing environments. Okay. Let me see. This page is getting refreshed. I could not able to see the questions. Okay, it's getting loaded still. A couple of minutes ago, I could able to see some questions, but again, it got refreshed automatically. We'll give some more time for that to get loaded. हाँ 1 minute. That is better.
Sir, meanwhile, you can. Uday sir?
Yeah, tell me, ma'am.
Meanwhile, you can ask the student to send the queries on this BOEIS-inter@ICI.in. We'll be forwarding the same.
Okay, sure. Students, I hope you listen ma'am words. If you have any questions, you can send to eisinter@ICI.in because there is some inconsistent issues on this chat box. Yeah, I could able to see now, but if any case, if I couldn't able to see the chat box, feel free to drop your queries to eis-inter@ICI.in. Okay. Anu Gupta mentioned that we are unable to attend the class on Board of Studies portal. If there are any issues, the technical team will be answering on it, Anu. Hiral Parekh, what is outsourced private clouds? Hiral, if you can give me the context, I'll be able to tell what is meant by outsourced private clouds. See, basically in general, by seeing the question, if those private clouds, let's say, instead of you managing it, you can take the services of some third-party service provider, but who actually owns it, who actually can control it is you only. Maybe you're giving that management activity to a third-party vendor, but ultimately the ownership and control lies within the same organization. Only that organization controls it. Okay, hope you understand these 4 cloud environments. Now let us see. Very high level I have given the definitions, but once you understand the characteristics, then you will be able to understand why somebody has to go for a private cloud or public cloud, or how an organization can choose which cloud environment will be suitable for them. Now see this from the control and management point of view. I have given in this tabular form. So I'll be taking each point and I will be discussing all these 6 points in the context of all these 4 types of cloud environment. So once you understand this tabular, then you will be able to understand what is meant by means what are all the different characteristics and how in real time the organizations can choose the respective cloud environment. From the control and management perspective, if you see, the private clouds are having high because as you understand from the definition, that cloud environment, be it software or hardware, resides within the premises of the organization. So since it is within your boundary, you will be having the high amount of control or management, right? If something is in your control, you can manage. If it is residing somewhere on the outside of your organization or maybe some other country, when your example in Google Drive, you and me never know where actually the documents are stored. All we know that from internet, I can access the document, but I don't know where that server is maintained or who is managing it, how they're taking the backups. None of the things are in my control. That is why on public cloud, the control and management is low. Whereas in hybrid, it's a combination, both private and public combination, right? We know that control and management is good in private environment, private clouds, whereas in public, it's not that great. So that's the reason they kind of averaged it. It's a moderate. Now, on community clouds, as only few organizations are part of that cloud, it is collaborative and distributed. Means only those 3 organizations can have that control and management. So I hope you understand the control and management perspective, how these 4 cloud environments works. Now from the SLA, this term we've been talking about from chapter number 2 or even chapter number 3. The SLA means service level agreement, students. Service level agreement means when you're taking services from an organization, so you will be having certain terms and conditions between the service provider and the service receiver. So in example, if I am taking a cloud ERP product from Oracle or SAP, I'll be entering into an agreement with them. So they will be saying how much time the instance should be up and running, and how frequently this can be refreshed. So a couple of things there you have to be talking in the service level agreements. So a couple of terms and conditions on those services will be drafted or captured in service level agreements. So if you see here under private, we kept as weak. Why the service level agreements are weak in private cloud? Because it is managed by the organization itself. So they are not that keen. See, if something is managed by yourself, you are little relaxed. You are not so concerned about it, because anyway, who are the users? It is your internal employees only. Even if it is not working, what you will say, hey, please wait for some more time. We are fixing that issue. But if you are taking the same service by paying a rent, you will have a demanding, right? You will be asking a question to Google. Hey, I'm trying to upload documents on Google Drive. It is not working. So you have to respond, because you are paying certain amount to an external party. He is bound to fulfill your services. So that is the reason the SLAs are very stringent or strict in public environments. So in hybrid also they say stringent, because as it has a combination of private and public, usually whenever it's not a cloud environment at all, that's completely a different technology. I will explain on that. Now, level of security. If you see the level of security on private clouds, it's high because it is within your control, within your boundaries of the organization. You are not exposing that software or a hardware to public domain like internet, where you have a high risk that somebody can hack your hardware or see some information on the software. So the level of security is high here. Whereas in public, it is low because, example, if you're using the Google Drive, anybody can hack and get the Google Drive credentials. So, and they can simply access it, right? Since it is on the public, on the internet. So if you understand private and public, understanding hybrid becomes easy because it's a combination of these two. So whereas they say it's a partial here because it has a combination of private and public cloud within the hybrid cloud. So community cloud also they say partial. Why? Because it is a group of organizations, right? So there is a chance of less security. One organization data can get accessed by another organization. So you can definitely define a lot of security rules and regulations, but still from the practicality part, there is a less security in community clouds because there are multiple participants. From the availability perspective, it is high to moderate, because on one time we can say the private cloud, since it is within your organization, you always ensure that service is up and running. But on the other side, sometimes you can't give that 99.99% downtime, right? The application sometimes go for a down. Whereas on public cloud, have you ever faced an issue the Google Drive application is not working? So they ensure that always the Google Drive services are applicable, or a OneDrive, or be it a Gmail. Always they ensure that the services are available across 24/7 by 365, because they maintain multiple servers. We will talk about one of the advantages of public cloud, the resiliency. So those kind of attributes are there in the public cloud. That's the reason it is always available. Whereas hybrid also, it's a combination of private and public. It is also available. Now, affordability means basically cost factor. The private clouds are not that cheap because you have to spend on hardware plus on the software. Both the things you have to spend and you have to manage. That's the reason the cost is very high in private cloud, whereas on public cloud, it is high. Affordability high means cost is low. Because on Google Drive or a Gmail, when you're using, you're not spending on email server, you're not spending on the maintenance of that application. So all you're paying is a rental. As I said, remember that car example. If you own a car, you have to spend for the car cost, and whenever there is a repair, you have to spend for the repair, right? So these two costs are there. In case of rent a car case, who spent on buying a car? The car rental person. If there is any repair happens, who will be spending on it? Again, that car service provider. From your perspective, you will be paying rent per month basis, maybe some 5,000, 10,000, depend on the car you take. So you pay the rent, you use the car. If any repair comes, again, it is a responsibility of the car service provider. So that's why affordability is high in public, whereas in hybrid, as it has a combination of private and public, they call it as a moderate affordability. And whereas in community cloud, comparatively cost effective. See, the community cloud is an extension of private cloud, basically. In simple terms, if I want me to say, private clouds, if we extend to multiple organizations, it becomes community cloud. But again, there is a limitation that only fewer organizations can see it. Okay. Now, on the scalability means expanding. So if you want to expand, it is a bit difficult in private cloud. As I said, let's say you want to have 2 cars immediately because you have some purpose. One car you want to send to one place and another car you want to send to another place. What you need to do? You have to buy 2 cars. So do you think buying 2 cars is affordable or scalable? Easily you can do that? No, right? You have to buy it. So to buy that, you need to have the heavy investment readily with you. So scalability is low here, whereas in rent a car case, it's high. Now I have 1 car. Even in next half an hour, if I want 10 cars, I can take on rent. So on public cloud, the scalability, the expandability is very high. Whereas in hybrid, it's a moderate because as it has a combination of private, so the scalability is low there, it's high there. So it becomes moderate. So community cloud, they didn't talk about the scalability perspective. So I hope you understand the characteristics of these cloud environments. So now you will be in a position to understand under what circumstances an organization can go for a private cloud or a public cloud or a hybrid or a community cloud. So now I could able to see some questions over here. Okay, Meenan, community cloud means in simple terms, see, you understand private cloud where there is only one organization, they are using the services of that cloud computing. Could be hardware, some software. So they are the only people who can use that application, let's say. Whereas in community cloud, the same application can be used by 2 or 3 organizations. So now you can come and ask, sir, why one software can be used by multiple organizations? Maybe they are all sister concerns, or they are all working together for a common problem. Example, a lot of pharmaceutical companies are trying to find a vaccine for the COVID example. Okay, they all want to add their synergy and want to figure out a medicine for COVID. So maybe to do that analysis, they might be requiring certain software or a resource. So all those organizations can come together and use the same software or a hardware, right? So because they are all working on a common purpose. So that's what I'm saying. It's not that necessarily every time they use, it depends on the purpose. Only when there is a need, they might go for community cloud, but they need to understand how the community cloud works. So that is what, if you understand these characteristics, then the organization will take an informed decision which cloud is best suitable for a given requirement. Now, let's go to the advantages of different types of cloud computing. So as you understand what are all meant by different cloud computing environments, let us see the advantages. If you see in the private cloud, it improves average server utilization, because instead of having multiple servers at different locations of your organization, let's assume you are an organization where you are scattered across the country, maybe at different geographies. So if your services of that hardware or software need to be utilized by your employees who are there in different parts of the country, so you can have one centralized server that gives a optimum utilization that can be given to all the people. So with one server, your job is done. So optimum utilization of your resources are possible. Then high level of security and privacy, we already discussed, which is, and this is small and controlled by the organization. So this is what you need to remember. The private clouds are small and controlled by the organization. So, or owned by the one single organization. Whereas in public cloud, it's low cost, highly scalable. As I given in the example, if you want to have 10 cars as a requirement, taking 10 cars on rent is much simpler than buying 10 cars, right? So it is highly scalable. No need of infrastructure. You don't need to have that infrastructure. Example, when you are taking the services of Google Drive or a Gmail, you're not spending anything on the hardware part. So basically for an email to work, you need to have an email server, right? The physical server and the related applications you need to have. But you can simply use the Gmail from internet and you need not worry about the maintenance and purchasing of it. And easily integration with private clouds. So if you want to integrate, means connect, integration means connection. So sometimes, as I said, there are certain organizations who use some public clouds as in hybrid. That's called hybrid, right? Where for their non-critical, means not that important activities, they use public cloud, because in public cloud, the cost is less, even though the security is less, they're okay, because it's not that data is means that needs to be secured a lot. So for those kind of things, they can use the public cloud services. So, and under that context, it can be easily integrated with the private clouds. No limit for number of users, because any number of employees can use the Gmail application. So similar to that. And stringent SLAs, because I'm paying rent and taking your services, I expect this service to be delivered at a utmost quality. Okay. But if you are using, say, let's say you're cooking something on your own in home. For some reason, maybe the taste was not came that good, or maybe as expected. Since you cooked by yourself, you're okay. You don't complain to anybody because you made it. Sometimes it might fail, but you still eat it. Now, the other case is you're buying from a restaurant, okay, where you pay a certain amount to the restaurant guy to get that item. He delivered the food. What happens? If the food is not in a proper temperature, you will complain. If the salt is little above, you will give a negative rating on the app. Maybe spiciness is more or spiciness is less, or food is not fresh. For any kind of small discrepancy, you will complain. Why you complain? Why you have not complained in the first case? In the first case, it is you managed it, right? In that case, even though something goes wrong, you're okay to accept. Whereas in the second case, you are paying money, you feel like you have 100% right or a demand or a like fundamental right given by the constitution, something like that we take, and then we keep bombarding the service provider, hey, you delivered a food, which is not good. So similar to that, when you're taking service, the organizations, if the service is not up to the mark, they will strictly enforce the SLAs, the service level agreement, what they had with the service provider. Now, if you see the hybrid, it is highly scalable because it has a combination of private and public. Whenever you have a public, that can be scalable easily. Better security than public cloud. Why? Because it has both private and public, right? So this is not that secure. This is more secure. So if you combine this, comparatively, if I take a pure public cloud, hybrid clouds are a bit secure because you have a combination of private cloud. Now on the community cloud, it is low cost private cloud because here there is only one organization. Organization A is accessing these services. Okay. Whereas in community cloud, the same service is taken care by A, B, C. When multiple people are sharing, so it becomes low cost. It enables collaborative work. Means, as I said, if all the organizations are working on one common objective, maybe finding a COVID vaccine, so they want to do some analysis. So they are using some cloud computing application or a hardware to do that analysis. So it enables the collaborative. They can come and join together to do a common task. Better security than public cloud, because in this community cloud, org A, B, C can be there. If org D or org 1 wants to access the data in this cloud, they cannot access, because the access is given to only these three organizations who are form part of that community. Then sharing of responsibility among the organizations. As I said, it has to be managed, the cloud environment, right? So as there are multiple people, the responsibility is also shared. So these are all the advantages of different cloud computing environment. Let us see the limitations as well. So from the limitations perspective, it is not as cost effective as public cloud, as we already understand. On the public cloud part, the issue is security, because as I said, when you're using some services over internet, you never know where the data is being stored. And also we discussed about control and management, right? You don't have a control. So if that document is stored in some server in some other country, you never know that who has given access to that server. If that server is or CPU is located in your organization premises, you can control who can access that server, right? So that's what security assurance is a limitation in public cloud. And privacy and organizational autonomy are not available. As I said, you don't have any control on public clouds. Whereas in hybrid, security features are as not good as private cloud, because it has a combination of private and public. We understand that in wherever you have a public cloud, you have an issue on the security. So of course, the same limitation will continue to hybrid environments as well. And it becomes complex to manage, because you have a combination. To manage those environments also will become complex. On the community part, security features are not as good as private, because it's just an extension of private cloud, right? Whereas there is only one organization here. On community cloud, you have multiple organizations. So security features are not as great. Autonomy also, individual organization will not have a complete control. Always the control lies within the combination of the organizations, and not suitable where there is no collaboration. That's what they're saying. If there is no common task, so why you need to share your resources to somebody else? So in such case, you have to go with private cloud. So this is the limitations of different cloud computing environments. So students, any doubts on these cloud computing environments? Let me see. Sometimes this page is getting auto refreshed. I could not able to see any charts, but I'm getting a WhatsApp screenshots. Yeah, Hiral, I answered on what is the meaning of stringent SLAs, service level agreements. In simple terms, terms and conditions. So if you're taking some service from an let's say on Zomato app, in the food order example, when you're ordering a food item on it, what is the service level agreement you have with them? They have to deliver the food within the given time. Let's say when you are ordering it, if they say it will be delivered in 40 minutes, you expect the food to be delivered in 40 minutes. Let's assume they have taken a 10 minutes extra. What you will simply be doing it, you will be raising a complaint on the chat box. Hey, I haven't not got my food. Okay. But whereas in the same case, if the same food is being cooked by you, you are preparing on your own. Instead of 40 minutes, if it takes 50 minutes, do you complain to anybody else? No, you're okay, because you yourself are doing the service. Even if there is any ifs and buts, you will compromise it. But if you're taking the service from an outside service provider, you will insist the terms and conditions to be implemented. Then, okay. Now I could able to see some questions here. There is a question from Mansha. Virtual private network is an example of hybrid. Cloud is a bit different from that virtual private network. VPN is being covered in our virtualization concept. Basically, this will allows through means the communication to your organization network or resources happens through a secured channel. Let's say I'm connecting from my home to my organization network. So it has to happen through a secure channel so that the data will not be accessed by anybody else. Scalability, I already answered, Mukta. Expandability. Let's say if you have one car, you got a need of having a second car. So if you want to buy the second car in next 5 minutes, it is very difficult. You need to have the lump sum cash and also the car should be available. But if you want to take the car on rent to meet your demand, it's comparatively easy, right? So that's what. Now, so this is about cloud computing environments. Now understand the cloud computing service models. So you have basically, at a broader term, you have three types of models: software as a service, infrastructure as a service, platform as a service. I will take you with an example. Okay. So again, this chart is not there in your syllabus, but for your understanding purpose, I have taken. Let's say there is an organization, they want to use certain software for their some purposes. I will take an example of ERP application because you are familiar with that application, and especially you know that these softwares, ERPs, are nowadays are available as cloud applications as well. So we can take this as a good example. Let's say the initial days before this cloud computing model comes into picture, if you want to use this ERP application, that's called on-premise deployment. So as you can see here, on-site or on-premise deployment, where the organization has to spend money on the servers. Okay. And all the networks and all the storage. As remember, students, when I'm talking about virtualization, the ERP to be installed, it takes some 400 GB, 500 GB of hard disk. So all those things are invested by the organization. So once the infrastructure, when I say infrastructure, all this physical infrastructure, be it service, servers, and the storage capacity, processing, the CPU capacity, and the networks. Because once I install the ERP application out there, it should be accessed by my employees. So how they can access from a remote location? By network connectivity. So all this physical stuff, the organization has to take care of it. Once everything is ready, you buy this software from, let's say, could be Oracle Corporation or SAP or even from Microsoft or be it any ERP vendor. So you buy from them and you can install it. You install this software on this server, right? And later, if you want to do any customizations, if you want to add any functionality which is not there in the application, that is also performed on this server or application. So the entire initial infrastructure cost, the upfront software purchase, you bought that Oracle or ERP from them, you might be paying annual license fees, but the entire software you bought it at one shot. So this is called on-premise or on-site. First understand all these methodologies, then you will be able to understand what is this IaaS, PaaS or SaaS. Okay, so this is the traditional way the software implementations used to happen. Now, if you see the Gmail or ERP clouds, I need not spend anything on this infrastructure part. All I need to do was pay rent. Pay as a rent. Okay, rent. I'm using rent as a simpler term, but pay as you go. So I will approach the same ERP vendor. What I say, hey, I have 100 users within my organization and I would like to use your ERP application. What they say, they will give username and password to all the 100 users and they can simply log into ERP application via internet. So where is that ERP application is installed? Where is that server located? You are least bothered. All you say to that ERP vendor, I want to have 100 user licenses where I will perform my organization transactions and record it. So if you see in this example, the hardware is not owned or spent by the organization. The application is not installed on the server which is located in the organization. I am paying a pay as you go or a rent to that service provider and utilizing their products. So that is called SaaS. If you see here, all these components are managed by the service provider. What are those components? I will explain. Don't worry. So if you pay rent and use their services, it becomes software as a service. So you are taking the software as a service and you are performing your transactions. Whereas in the first case, you manage, you bought the hardware, you bought the software from them, you installed on your software and start using it. So if you understand this versus this, then understanding these two is a bit easy. Okay. Are you clear with this? on-site versus SaaS deployment. Students, any doubts on this? I'm taking bit amount of extra time on explaining these topics because this is one of the important and bit complex. The rest of the topics we can quickly complete because those are not that technical in nature. How community cloud uses private cloud? Hiral, community cloud, as I said, it's an extension. I never said it's a private cloud. Where, see, in private cloud, you know that, right? Only one person is using it. Whereas in community cloud, multiple people are using it. Example, if you extend the car example, if you spent the entire amount and bought a car, you alone are using. Let's assume along with you, two of your friends also joined, and you bought a second-hand car because you all want to learn the car. Okay, there the purpose is you want to learn the car. So spending on a high-end car and damaging it while you are learning is always costly, right? Instead of that, you all together, you share the cost, 30,000, 30,000, 30,000. By using 90,000, you bought some second-hand car and you are practicing on it. So in that model, all three of them are equally owned. If any issue comes, all of them are being shared, something like that. So that's how the private and community cloud works. Okay, so students, I hope you understand the on-premise, the left side, where you manage everything. Whereas in SaaS, all you do is pay rent, take the service. That is what SaaS. The in-between model, IaaS and platform as a service, if you understand here, let's say up till here, the networking, when I say networking, all those network cables, storage, the hard disk, servers, CPU, processing, all those stuff, virtualization. You remember that virtualization concept? This comes under the category of hardware requirements for an application. Whereas for that application to work, example under applications, take an example of ERP and the data means transactions. Okay. So the runtime, middleware, all this comes under development environment on which you can install these applications. Finally comes the ERP, the applications or the actual software. So I have subdivided this list into 3 blocks. If an organization is managing the entire part, okay, this is called on-premise deployment. On-premise. If they manage only the hardware part, this is called, means you are outsourcing this work to a service provider. If you see in this diagram, the ones which are in red color are managed by the service provider. Let's say in our example, the ERP vendor could be Oracle or could be Oracle or SAP or anybody. So if they are managing it, it's called infrastructure as a service. So these are managed by the service provider. The rest of the things are managed by the organizations. So here, what kind of service I am taking? I am taking the service of infrastructure. Infrastructure is by them. The rest of the things I manage it. It's called infrastructure as a service. Now, if you just extend it, apart from the infrastructure, the development environment also managed by the service provider. This is called platform as a service. So they provide the infrastructure and also the platform on which my software can run. These two are given by the service provider. So that is called platform as a service. Now, the third one, if everything is given by the service provider or managed by the service provider, it's called SaaS, software as a service. Example, like Gmail or a Google Drive, we're not bothering about anything. They are managing that application completely. All we are doing is open an internet browser or a Chrome browser, www.gmail.com. You are getting access to an email application. You are not concerned about how that email server is connected to your home. You are not concerned. How that email server is managed or secured. You are not concerned. How the Gmail software is developed or managed. You are not concerned. All you're doing was taking the services of Gmail and sending and receiving your emails. So that is what SaaS. So I hope you understand. Students, again, this is not a cloud computing technology part for you to understand, but understand at a very high level. What does that mean? How these are practically works in real-time world. Sorika, can we get the schedule for May and coming months of LCC batch? Please drop, and because I'm not aware about that, you can connect with the Board of Studies team. Hitesh, if they have asked, definitely you can present in tabular format. See, our exams are professional exams. They don't expect you to write in as per the textbook, right? All you need to is convey the answer to them in most appropriate way. I don't see any limitation if you put it in tabular format. Adit, is there any software that makes use of our storage as a cloud storage, assuming that our external SSD is connected to internet? Of course, Adit. Nowadays, if you see Western Digital, a lot of companies are giving that My Cloud. If you go to Amazon, there are certain hard disks which are having that software inbuilt within that hard disk itself. So once you connect it to the internet, you can access that storage capacity from any part of the world. You might require some login. There might be some website to control your hard disk. Definitely, you can do that. Let me show you that. Yeah, you see here. So this is one of the example you are talking about, the My Cloud. So it looks like a simple CPU, but basically you can connect this hard disk to the internet and you can access that storage space from anywhere. So as you see that uploading in Google Drive or uploading in Microsoft, you're little concerned about your data. Let's assume, okay, you don't want to dependent on those services. You can definitely buy this, keep it in your home, connect to the internet, and upload all your data to this hard disk, which is physically located in your premise, and you can access from anywhere. This is absolutely possible. Fine. Let's move on to the next topics. So I hope you understand now the cloud computing service model. As I said, if everything is managed by the vendor, it becomes a SaaS product. If the hardware part is managed by them, it becomes infrastructure as a service. They are giving the infrastructure on which the rest of the things are managed by you. Apart from hardware, if they are giving the platform as well, hardware plus platform, it becomes platform as a service. Okay. So these are the three models. Now let's get into the definition part. It will not take much time. I'll be skim through it. So if you see here, infrastructure as a service, it's a hardware level service that provides computing resources such as processing power, means the CPU, memory, storage, means the secondary memory, RAM, hard disk, and the networks for cloud users to run their applications on demand. Let's say you have certain application, but you don't want to spend on the infrastructure. If that is your requirement, you take infrastructure as a service, you deploy your software on their infrastructure and start using it. So what is the advantage? You need not spend amount on the infrastructure. You need not worry about maintenance of that hardware, right? That's an advantage. See, nowadays, lot of companies are building software applications. So for them, this is a good advantage, right? They need not spend on hardware. All they can focus on the software only. So they develop the software on their own resources and deploy it. When they are installing it, they deploy it on cloud infrastructure. So that is somewhere located far from their organization. So this is about infrastructure as a service. So what it does, it allows the maximum utilization of computing capacities without having to own and manage. As I said, you need not own it. You need not manage it. You take the services of them and just complete your work. So the end users or IT architect, they will use the infrastructure resources in the form of virtual machines and design virtual infrastructure. So I'm not getting into it because we understand what is meant by virtualization. So how they can access that physical server using virtualization, they can access. So there they can deploy their softwares. They can check whether it is working fine or not. All those things they can access by remotely located. So this is what infrastructure as a service. If you see the characteristics of, so you can access via internet, web access to resources, centralized management. That means you can manage from the central console, means which infrastructure, which server I should be using it. All those things can be managed. Yeah, this management console from a central location, you can manage. Elasticity and dynamic scaling. As I said, let's assume you initially take a server of 100 GB or a 1 TB capacity. Tomorrow you want, hey, a 1.5 TB. Then you need not buy that 0.5 TB extra capacity. You can tell to your service provider, hey, can you increase the storage space in my server? So they will do it. They might charge extra amount for as a rent, not as an upfront cost. So that is what elasticity and dynamic scaling. Shared infrastructure, as the same infrastructure have been shared to multiple people, the cost will come down to the individual user. Metered services, as I said, you will be paying it on the usage part, be it number of hours or be it the amount of TB you use. Some parameter they will decide. Based on that, you will be charged. Now, so there are different kind of instances of IaaS. There are different variants of IaaS. You can take the services of network, means only for networks you can approach them, or you can approach for storage capacity, or you can approach for database as well. So they will just explain what is that, but theoretically based on the requirement. So if you remember this diagram, network, storage, server, virtualization, all these are coming together as infra definition, right? You can take only the networking capacity, only you can take storage or server or databases. So based on that, you can take it. That's what the instances of service means, the various variants of IaaS. It's a backend, means if you're developing certain application, you need the backend applications where you can deploy and test. That is also possible. And desktop as a service, that virtual environment we talked about, right? So these kind of models you can be expect in IaaS, infrastructure as a service. Platform as a service, I am coming now, Hiral, wait a minute. So I hope you understand what is meant by infrastructure as a service. Now, platform as a service, when you are taking services as a platform as a service, you are taking from them the infra part. When I say infra, the CPU, processing, storage capacity, networks, all those things which you can see in the computer environment, plus the development applications. See, if you need to develop a software, you need to have an operating system, you need to have a runtime environment, okay, where you can test your application. When your software need to be tested, you need to have a runtime environment where that can be executed, whether it is working fine or not. So all these things are form part of this development platform, okay. So if you take these two, that becomes PaaS service, platform as a service, both underlying hardware. Apart from that, the development environment also, you are taking them from them as a service. So it provides the ability to develop and deploy an application. Deploy means install an application on the development platform provided by the service provider. See, this you will be able to understand if you know the system development lifecycle. If a software needs to be developed, it has to go in a multiple phases, right? Initially, you have to write the program, right? And then you have to test it. You have to test it multiple times on the environment, on the platform. And then finally, it will be given to the users. So to develop and test, you need a lot of applications or a lot of softwares. So if all those things are provided by the service provider, it becomes platform as a service where you can develop it. Let's say, I'll tell you, if you apply to my cooking example, you want to cook a dish. If you need a stove, you need the gas, you need utensils. So these are the hardware part to it. Now, what is the development environment? You need a couple of things like some raw material and all those stuffs are needed. So those are become the platform with which only you can test and you can prepare the food. Finally, when the food is ready, it's a final product. So if that food, if you ordered, it become a SaaS product. If you use somebody gas station and prepare it, that become infrastructure as a service. All you're using is that gas, whereas the raw materials, everything is belongs to you. So that's how you can bifurcate these examples, means these models. So under platform as a service, if I go back to the technological terms, the underlying infrastructure and the development environment belongs to the service provider, where you use them and build your applications. Now the third one is software as a service. Here it's very simple. All you're doing is everything belongs to them. You are paying money and utilizing their service. Simple to that Google, Gmail or OneDrive or any other thing. Organization parlance, they have used a lot of products. Example, there are a lot of ERP products available on cloud where the organizations pay on a monthly basis the service fee to them, and their users will use their applications, which is installed on cloud environments. So if you see here, the end users get an access to the application over internet, which is hosted and managed by the service provider. You need not worry about it. The least bothered model is software as a service. So under software as a service, you can take different kind of software, means different kind of services. The testing environment you can take as a service. API means application program interface. So basically, there are two environments in your organization. If you need to transfer the data from one software to another software, the interline means the bridge is called API, application programming interface, where the data can be imported or exported from one software to another. So that service also you can take from the service provider. Email as a service. If you want your email applications to be managed by a service provider, so you can take email as a service. So, and again, there are a few other models they are saying. Communication means within your organization, if you want to communicate with your team, you can take communication as a service. Example, the right example for us, now I'm using a Zoom application. Let's say our ICI Board of Studies have taken Zoom application and they are paying certain prescribed fee to Zoom service provider, through which you and me are able to communicate and connect, right? This is a perfect example of communication as a service. Basically, to communicate with the students, we have taken a product from the Zoom, where all I'm doing was I'm not managing the Zoom application, all the required hardware infrastructure, the software development. I'm not taking any of their headache. All I'm doing was paying money to them and taking this service. So this is a beautiful example of communication as a service. Data as a service. Let's say there are certain organizations like stockbroking companies or fintech companies where they're looking for a lot of market related data. The data alone can be shared by the service provider and you can pay certain fees to them. That is called data as a service. Security as a service means within the organization, if you need to build the security, there is a lot of things you need to take care of it, both from hardware and software. If all these things are taken care by the service provider, it becomes security as a service. So in simple terms, whichever service you are taking from them, that's the definition, that becomes the definition. Identity as a service, when I am logging into my means the organization resources, I need to get authenticated, whether I am the right person to access that resources or not. So to authenticate, they'll be having that in certain softwares and applications or a certain protocols to be managed. All those things are outsourced. So a third party is will be taken care by identity part. So if you are consuming that service, it becomes identity as a service. So as I said, just read through the definitions. If you have any further doubts, again, feel free to drop to eisinter@ici.in. So these are the various instances of cloud computing. Now, what are all the issues related to cloud computing? So far, we have seen the advantages, characteristics, different types of cloud computing environments and service models. What are all the issues now? Threshold policy. As I said, we have discussed about one of the characteristics, elasticity. That means when needed, I can expand it. But you should be defined very clearly till what extent they can support. Let's say I need one car. I'm using one car on rent. All of a sudden, if I say I want 500 cars, can they able to arrange? Right? No. We should be very clear till what extent they can support, so that you will also know, hey, this guy can support up to 100 cars if I want. If I want 200 cars, definitely this person cannot render that service. So that threshold policy should be defined apart from the SLA. SLA says, I will provide one car. What are the terms and conditions? If the car has stopped or break down anywhere, I will take care of it. You need not worry. You can park the car, intimate to me. I will take care of it. So that will be covered in SLA. But let's say if I want 100 cars, whether this guy can provide or not, usually the SLA will not contain. So you need to have this additional term, threshold policy. If I am going up or going down, if I want to come down, what is the threshold means what is the percentage to which I can go up or down should be defined very clearly. Interoperability means the same software works on multiple platforms. Let's say if you are working on one cloud vendor, you have taken a service from one cloud vendor. Tomorrow you want to move to another cloud vendor. There are a lot of integrations, means connections are established to your organization applications to the cloud application. So all of a sudden moving from one application to another, those things should be workable. Okay. If they say whatever you have spent money to establish this connection, if everything is not working for the new vendor, then it's not a great cloud computing product, right? So try to have interoperability so that you can move from one cloud vendor to another cloud vendor. Hidden cost. Sometimes, usually it is very transparent, but some service providers, you should be very careful that the rates are very clearly called out. What are all the example, if I am scaling up, especially in a peak time where other users also asking for the same storage or a computing capacity, how much extra charge you will be charging it, you should be clearly calling out now itself. And unexpected behavior. That means sometimes certain applications works very good when you're installing on your system, but the same software, if you are keeping on cloud, it may not work. So that kind of inconsistencies or unexpected behavior can happen. Security issues, we know that, of course, when the data is stored outside of your organization, it is always risky. Legal issues, certain countries have certain issues or certain limitations from the legal perspective. Example, I heard in one of my previous clients, in China, any company, if they are putting a company there, the data should not be stored outside of China country. If you are operating from China, the data relating to the transactions should be stored within China. You can't use a server from US or a server from India. So they have certain legal requirements. So if you are in such kind of environments, this cloud computing, when you are implementing the cloud products, so be careful about the legal requirements. Software development in the cloud, why they call it as a issue here? When you're building the applications which are basically deployed on the cloud environment, of course, it is a bit complex because if something have been utilized locally, means the development from the technicality part is easier. But if you're deploying a cloud product, the development is a bit complex. How to establish a connection, how to ensure the security, lot of other factors should be taken care. The bugs in large scale distributed system, what they're saying, especially on a cloud products, let's say if there is an issue you found in that software, then fixing that issue on that cloud product is a bit difficult because there are multiple users are using simultaneously. So when compared to an on-premise software application on this cloud environment, fixing the bugs is a bit challenging is what they are saying. So these are the issues related to cloud computing. Hiral, backend as a service means you'll be having certain softwares. Let me go through that. If you see here, the web and mobile app developers, if you know the app development, so there is an app here, what you and me see, but on the back end, it needs to connect to some servers. Okay. So the connection part is what they're talking about, how to establish a connection to those servers and how to authenticate the user management, how to send a push notification to the app, lot of things on the application part, how to establish, example, from that app, you're navigating to a social media platform to give a rating. So how to establish that connection to that social media platform. So a lot of things you might be required to be performed on the backend part of the application. So these services also you can take from a service provider. So this is what they are saying, backend as a service. So I hope you understand the cloud computing models. Let's take a quick assessment. Development platform, Karthik Gupta. It's a one-time activity. I need to get more details to answer you. Let's say if I am developing a software, establishing the development environment is only one time for sure. How you are buying the server or a CPU one time, similarly the development environment is also one time. But if there are any bugs in that environment, you need to manage it, right? So that maintenance is your headache. But if you're taking from SaaS model, you need not worry about it. It's completely taken care by the service provider. Students, can you please share your responses to these queries? Then we can move on to the next interesting topics lined up for today. Let me see the answers. Question number 1A, I'm seeing right answers from Hitesh, Himanshu, Deepak, Mansha. Correct. So all the answers are correct. I am happy to know that you guys are able to follow, though it's a bit technical. See, all these emerging technologies, every topic is newer technology. So you need to be attentive to understand the concept behind it. For sure, you need to read through it once again from your book. If you have any doubts, feel free to drop an email to EIS-intro@ICA.in. Because as I'm introducing you a lot of technical concepts in this 2.5 hours, maybe sometimes you might not be able to follow. Listen the classes carefully, listen the examples, and then you'll go back and read through the chapter once again. And if you have any doubts, you can drop an email. Good. So Harshita, Meenan, Shreya, Yukti Jain, all have given a right answers. Good. So you are able to understand the concept. So as I said, in cloud computing, the most important topics are cloud computing environments and service models. So so having the understanding on this definitely will help you to get a good marks in the exam. So this is about chapter day 3 topics, the leftover topics. I hope we are good with this. Let's quickly move on to our day 3 topics. So as I said, we have a couple of other topics lined up. The next topic is mobile computing. Okay, these are very simple concepts, not that technical in nature. We can quickly complete these topics. So what is meant by mobile computing? So far we have seen virtualization, green computing, cloud computing. Similarly, now we are going to understand what is meant by mobile computing. So understand the definition, then I will give you a realistic example. It will be easy for you to understand. Mobile computing refers to the technology that allows, so first and foremost, it's a technology that allows transmission of data. Transmission means sending or receiving the data via a computer without having to be connected to a fixed physical link is called mobile computing. In simple terms, let's say you are in this organization. Okay, you have a system here, you have a server here. To access the services, you are connected via intranet. Using cables, these two systems are connected and you are accessing the data or a service from this server. Okay, now the other example is the same organization A, you have the server here. Now you are not in your organization. You might be working from home or you are a sales guy. Okay, you will be in the field to interact with your customers, get the orders and all those stuff. You might be using some mobile, but and when you are discussing with your sales guy, the prospect customer, you want to check the price list, okay, or the stock availability of that particular item. Where that information is available? In the ERP, which is installed on your organization premises, but you still be able to connect remotely to this application, get the data and get the work done. Similarly, if you are working from home, you can connect to your applications or softwares which are there in your organization from your home and then get the job done. So you understand the difference between these two scenarios. In scenario 1, the devices are physically connected to this applications or services. Whereas in the second example, you are not connected directly. You are connected via internet. Okay, using a public internet. But still, you will be able to complete your job. This is called mobile computing. Here, mobile doesn't not necessarily mean the mobile device. Mobility means movement. You are not fixed to one location. You can do the same job by connecting to your resources from different locations is called mobile computing. So don't get confused that mobile computing means anything you do using your mobile. No. Here the context of mobile means mobility, not in a fixed location. but predominantly you can use mobile devices because you always carry mobile with you, not the laptops or desktops, right? So that's how they are saying here. Now, if you further read to the example, it become mobile data communication has become very important and rapidly evolving technology, as it allows users to transmit data from remote locations to other remote or fixed location. So this proves to be the solution to business people biggest problem on the move. Let's say if your employees, most of your employees are always outside of your organization and they want to get the things done, for them this technology helps them to solve the issue. Basically, yeah, this is what, if you see here, it's an umbrella term used to describe technologies that enable people to access network services from any place, anytime, anywhere. Okay, so wherever you are, in whichever time zone you are, you can still connect to your resources and get the job. This is called mobile computing. I will explain, Vinay, how there is a question from Vinay, how mobile computation is different from private cloud computing. I will explain that. Now, first, let's see components of mobile computing. One is the communication, the infrastructure which establishes that communication. The second one is the hardware part. You need to have the front end and back end. And the final one is mobile software. Don't worry, I will come back to these components once I give an example. This you need to understand the working of mobile computing. I'm taking an example. Now let us see whether you are able to follow or not. Let's take the same organization A. I have my ERP installed in my organization. You know what are all the functionalities of ERP. Let's talk about the sales and distribution model, distribution module, where basically it is for the sales people. So if you can visualize the sales department structure, you have your sales associates who basically on the field to meet the customer, get the business so that organization can sell their products. So that is what your sales consultants or sales associate. And you will also have your sales manager. Okay. So let's assume there are two people. One is a sales associate, another one is a sales manager. If you see, most of the sales people will not be sitting in the office premises because their primary job is meeting the customers, new customers, get the business, meet the existing customers to understand if there are any issues or update the status on their orders or try to get more business. So most of the times, 80% of their time, they'll be always roaming outside of their office premises because that is what their job, right? Now, let's say one of the sales people, they went to a client. Let's say this is organization B. This is their client. Okay. Now, when they are meeting with this client, they are in discussion. So they are trying to understand, hey, you're getting a lot of business from our company. Are you facing any issues? Or at the same time, they are trying to get more work or more products or more orders from this organization B so that their sales will go up. So they're actually outside of their organization in one of the meeting. Now, what happens? One of the person in their organizations, they are booking a sales order in the ERP. One of their another team member, one of the sales associate, they got an order. They're booking an order, sales order, customer order in their ERP. As part of the internal process, any sales orders which are entered in the ERP has to be approved by the sales manager. Because before we are committing to the customer, somebody from your department, means who are above the regular sales people, the department manager should approve it. This is the policy. So whereas the sales manager is sitting physically in organization B, he is here, he is discussing with another client organization B. Whereas one of your sales representative is booking an order, let's say for organization C, as part of their day-to-day job. So this sales order is went for an approval. It has to be approved. But physically, this manager is not located in the organization. What is the option you have? When the sales manager comes back to the office, then only he can approve if it is a regular pattern. Okay. But with the help of mobile computing, the sales manager is having a mobile. Of course, everybody have a mobile. He will also have there. This ERP has given a mobile application. Okay, how you and me use lot of mobile apps, even the ERP also have given an application, which that application is installed on the sales manager mobile device. Okay, when the sales order have been booked and it requires an approval, it gives a notification. How you get a notification on the mobile app. Similarly, he also got a notification. Hey, one of your team member booked a new sales order and this order requires your approval. So this sales manager, even though he is physically located outside of the organization, he can review this notification, and if everything is fine, he can approve it from his mobile device. Okay, remember students, all he's doing from his mobile device. Once he approves, what happens? The approval notification will goes back and update the status in the ERP for that sales order. Previously, it is in the in process state. The moment he approved, it will be updated as approved. Okay, as the sales order is approved, it can go for the next steps. Let's say if it is a trading business, as the sales order is approved, the goods can be shipped. Or if it is a manufacturing organization, the sales order can be sent to production department for starting the production. Any steps can be done once the sales order is approved. In this example, even though the sales manager is physically located outside, he can still access the application and approves the notification. So this is called mobile computing. Now read through the working of mobile computing by keeping in mind my example. The user enters or accesses data using the application on a handheld computing device. In this case, user means our sales manager. So he will be accessing the approval notification on his mobile device. What he is doing? Using one of server computing technologies, the new data are transmitted from handheld to site's information system. So here it's called ERP. Let's say in our example, it's an ERP system. The moment I say approve, that approval status has to go back to my ERP, and the files are updated and the new data are accessible to another system user. In this example, the salesperson or associate who is sitting in the organization, he only created the order, right? The moment his manager approved from a remote location, he can check in the system. Now this sales order is approved, right? Now both the systems, handheld as well as site computer, they have the same information and are in sync. That means the same sales order now in the ERP, this sales associate can see it as approved, and also the sales manager using that app, he can also see the status of that sales address approved. So both this handheld device as well as the ERP, it shows the same level of information. Now, the process works the same way starting from the other direction. So if you start from here, it happens the same way. Now, all this example comes from, they have explained with this direction. If you start from here, it goes the same way. So the data flow is not matter. All you need to understand how this flow works. Students, have you understood the working of mobile computing? So if you understand this example, this is what mobile computing. So that's why I was more interested to explain this example. Now I'm going back to Vinay's question, how mobile computing is different from private cloud. Now, if you see here, this ERP is installed on the organization's hardware, means organization CPU. The ERP maintenance is managed by the organization. It's not a cloud environment, right? So it's just an ERP application where you can access via internet. So it's an extended application so that you can access. So these, I think I can understand your doubt, but technically speaking, this mobile computing not necessarily mean the private cloud. Cloud should have that characteristics. Okay. So any other questions on this, students, on the private mobile computing? Now, if you see the components of mobile computing, if you can visualize that example, first and foremost, you need to have a communication, means the infrastructure should be in place to ensure that the seamless and reliable communication goes on. So this would include the common communication properties or protocols or data formats. Means when somebody approved on mobile app, the data should come back securely to the organization ERP environment. So you need to have those protocols or security mechanisms to ensure that the communication happens very secured way. The hardware part, front end, as I said, in that case, he might be using a mobile device, or you can also use some tablets. So if you see nowadays, many people, even if you go to a restaurant, let's assume you go to a restaurant, nowadays many restaurants has given a tablet to you, where all the items you ordered, they will be entering on the tab. The moment you say these are all the items I want, from your table itself, they are confirming the order goes to the kitchen, back in the kitchen, and they can see that order details, and they can prepare the food and update the order status. The food is ready for delivery, right? So that is also another example of mobile computing. On the backend part, of course, you need all these application server where that software is installed, database server where the data is installed, communication server, the wireless access protocol, the web gateway, and a couple of servers on all the backend part. So even one of the student was asking about the backend, right? If you see, these are also form part of the backend where actually the process happens. And finally, the mobile software, the mobile operating system, and mobile apps. So that mobile could be Android or iOS, and the app. So these are all the components which form part of mobile computing. So now remember those examples, be it that restaurant example or the ERP sales order example, you'll be able to understand what is meant by mobile computing. So if you see the benefits of mobile computing, as it's very easy to understand, you can work from anywhere. So the sales manager need not physically present in the organization. Now, what it helped, it reduces the time or a dependency. He need not physically present, but still the process can move further. And it provides remote access to documents or files over a secure channel. It enables the organizations in providing improved services to their customers. Why? Because, example, as the sales manager is not physically present, if we say to the customer, to the another customer, hey, I'm not able to proceed with your order because my manager is not physically present. So once he come back to office, then only I can take up. If we say this, maybe the customer might get disappointed. Now what happens? Everything is completed as expected. So there is no dependency, there is no hurdle or a blockage, right? So this actually helps in improving the services and improve the management effectiveness as well. Why? Because as you are able to perform these services remotely, even from the management perspective, if they want to check whether these orders are progressing, any kind of information, even they can also take better decisions by accessing that information, even though they are not physically presented. Facilitate excellent communication. We have seen a classic example, even how he can say that this order have been approved. Instead of calling and saying that, hey, I'm approving this order, he approved on the app, and that has an audit trail and a proper secure mechanism. The data came back to organization and updated the order status as approved, and improves workforce productivity. Of course, now as we have seen, the sales manager, by located physically outside of the organization, can still complete his job, which is assigned to him. So it improves the productivity. These are very straightforward benefits of mobile computing. So let's see on the limitations part. Of course, for every technology, you have plus and minus. The limitations, what they're saying, insufficient bandwidth. If example, if the sales manager went to a location where he don't have a proper signals, then he can't able to do this job. And security standards. However, we say we are following all those security mechanisms to ensure that the data is transmitted securely. As you are using public internet, see, you might be using the VPN connection or VPN channels, some secured channels to transmit the data. But again, it comes via public internet. There is always a security concerns. Power consumption, as you are using your handheld devices, sometimes what happens? What if your mobile phone is switched off or drained out because of the battery consumption? You can't perform this job. So that's what they're saying. Power consumption is also one of the concern or a limitation. Transmission interferences. That means while sending the data, sometimes something can break out. The moment you approve that notification on your mobile phone, he says that, hey, I have approved from my side. But sometimes on the ERP, the transaction might not get updated. So that kind of chances are always happens, because you are ensuring that you are communicating between two systems. Sometimes the communication between while transmitting might get lost, or sometimes the applications will not process as expected. See, now in this example, the mobile device ERPs are there. The data have been transmitted via API, application programming interface. This is what I was saying. So using this technology, the data will be transmitted from one system to another system. Potential health hazards. Why? You've been now, previously you've been using your mobile phone only for calls. Now for your office purpose, you tend to use more and more mobile handset. So of course we all know that mobile handset comes with a lot of disadvantages, like your eyes get strained and you will have a radiation impact. So a lot of health hazards can happen. Human interface with the device, and you tend to spend most of the time on devices. So that also kind of a limitation on the mobile computing part. So these are the limitations of mobile computing. So technology wise, it's not that complex. It doesn't have, unlike cloud computing, mobile computing doesn't contain any technological topics. All you need to understand, you are using certain devices to remotely connect to the environment in your organization, transmit the data via secure channel, and get the things done. So this is about mobile computing. So students, can you please share your responses for this assessment question, just to see how better you understand this example? Meanwhile, I'll read through the chat box. Example of Suzuki financing from anywhere on mobile is also an example of mobile computing. Hitesh, I'm not aware about what is this Suzuki financing. Are you talking about giving a loan from your home on a mobile app? Is that what you are referring? If that is the case, yes, you can say. Students, please share your answers to this question, and then we can, once we complete this assessment, we'll take a break for 10 minutes. Answer is D. I'm seeing a first response from Harshita Agarwal. Correct, Harshita? These are all the steps. Okay. See, whenever you got these kind of questions, try to use that elimination part. Like, which of the following is the correct sequence? First, the user, right? If you read these four, the user enters or access data using the application on a handheld computing device. So that we know that this is the first step. So out of the given answers, which answer is starting with 1? So here A, C, D. So for sure you can eliminate B. Now both the systems have the same information and are in sync. We know that once the sales manager approves from his device, that is the next step. So definitely 2 is not the second in the sequence. The process works the same way starting from the other direction. This should be the last. So you know that this should be first and 3 should be last. If you see here, out of A, C, D, this is not the one which have the 3 as a last. C and D have the last one. So out of these 2, 1 will be the right answer. Now we know that this is the next but 1. So 1, 3, 2, 1, 3, 2. So then you figured out the D is the answer. So you can just try to do that elimination part so that you will get the less answers and then easy to figure out the sequence. Except one student, I see almost all the students have a given right answer. So I believe that you understand that example. That's why you were able to rightly give answer to this. Good. So we are done with mobile computing. The next topic is grid computing. Now it's a 7:40. Let's take a break for 10 minutes. We will resume at 7:50 and continue with the rest of the topics. So these grid computing, what all the rest of the topics we have, BYOD, these are very simple, not that technical. These are straightforward, like 10 minutes we can complete each topic, something like this. So by 8:30 we can complete all the topics, and then maybe some time you can spend on discussing your questions, any of your doubts. We can also see a couple of past examination stuff. So fine, students, let's take a quick break for 10 minutes. We'll come back at 7:50 and continue with the rest of the discussions. I hope all the students are back. Okay, so now the next lined up topic is green computing. So far, you've been talking about cloud computing, grid computing, virtualization, cloud computing I already covered. So whenever you see this word, you thought it's a technology, but this is an exception to it. Green computing is not a technology. You need to understand fundamentally here, it's a policy basically. Okay, I will start my explanation with an example. Let's say in your organization, we have, I'm not sure how many of you are working in corporates or any kind of medium-sized firms. If they say that unless needed, don't print, there could be some policy, maybe on the emails also, they will write at the end of the email, unless required, don't print it, to save the paper, or always switch on the lights or electricity only when it is needed, right? Why all these precautions? To save the natural resources. It's not that you can't afford, even though you're okay to pay that extra bill to generate that electricity, to generate that power, we will be destroying certain natural resources or consuming certain natural resources which can't be get it back easily. So green computing talks about all those policies within the organization so that you can be socially responsible as well. You remember in chapter number 2, students, when we are talking about ESG, environmental, social and governance reporting, I have showed one of the example or one of the report given by ICICI Bank on the day. So they talked about 9 million sheets of paper have been saved by discontinuing their physical delivery of email statements. Nowadays, most of us are getting our account statements via email. So this is part of that green computing. So what the green computing says, it's a policy that should be adopted by the organizations to conserve the natural resources in simple terms. Okay. Now, as you got the context, now let us read through the definition. Green computing or green IT, okay, it has another name. It refers to the study and practice of environmentally sustainable computing or IT. So whatever you are doing, it should be environmentally sustainable. So especially offices, what are all the things you can remember? One is paper, then electricity, and all the electrical equipment, and maybe if they are manufacturing organizations, the packing materials. So these are the couple of things I could able to recollect. If you know any other things which might have an impact on the environment, so do list out here on the chat box as well. All those things, you should have a policy to ensure that these are very cautiously used. In other words, what they're saying, it's a study and practice of establishing or using computers and IT resources in more efficient and environment friendly and responsible way. So students, green computing, as you understand from the definition, is not a technology. It's a study and practice of establishing or using computers or IT resources in more efficient and environment friendly way. Let's say in your home, I believe most of us always forget to switch off the lights or fans when you are moving out of that location. What our parents says, hey, switch it off when it is not in use. So that is also part of green computing. If you extend the same thing to an organization, if the organization have policies to safeguard all these natural resources, it's called green computing. This definition is fine. Now, if you see a couple of examples, develop a sustainable green computing plan. How this can be implemented in the organization is what they're saying. So how that can be done? Develop checklists. So put like this is what I was talking about. If you're working in a company or a firms, most of the places they will put a checklist, especially in cafeteria and all. Don't unnecessarily waste the water. Don't near to the printer. Unless it is required, don't print it. If possible, try to print both sides of the paper. or wherever required, use only black ink color instead of avoiding the multicolor prints. So in whatever capacity, whatever possible way, you can save these environmental resources. They will be prepare all those checklists and keep it in the on the walls or the places where people using those resources, and also the recycling policies and recommendations for disposal of used equipment. Basically, I can tell you a live example. In one of my previous organization, we used to have a big box where any of us in our homes are using some electrical equipments, be it lights or even some computing related one, mouse or a keyboard. If something is not working, you and me, what you will do, either you will keep it with your home or you will put it in the dustbin where the garbage guy takes and put it in the garbage place. So that item is not gone for recycling. Instead of that, there is a separate bins where they will collect all these things and send to the e-waste reprocessing people. So they know the process to recycle these items properly, and wherever possible, maybe certain components from them can be reused. Instead of remanufacturing, they can be reused. So organizations should have all these policies so that you can save something from the damaging the environment. If you see here, encourage the IT community for using the best practices. As I said, in our office, whenever we go on the meeting rooms, so they will put a caution there. So switch off the lights, switch off the monitor, switch off the projector when you are not in use, something like that. Ongoing communication about green IT best practices. You keep updating your employees that these are all the policies one should follow. Include the best practices for saving power usage or a paper consumption, as I shared in the examples. And use the cloud computing. So what is the advantage of cloud computing? We have seen various models, right? Let's say if the same application or a server needs to be like, instead of giving CPUs for multiple people, you can have one server, store the data here and ask all your employees to access. So you could have saved money. That is eventually one of the benefit of cloud computing. On the other thing also, even though you are okay to spend that money, instead of buying 10 CPUs, now you can buy only one CPU. So to produce a CPU, how much plastic or those electrical equipments need to be like to be manufactured by using the natural resources, all those are being saved by following this green computing plan. So this is what they're saying. Now also on the recycle part, if you see here, dispose the e-waste, especially in organizations, e-waste is the biggest challenge. Lot of laptops, mouses, keyboards, headsets, so which are damaged, which can't be repaired. So they're all lying in the organizations with a big junk. So as per the government guidelines, you have to dispose of them, because if you throw out all these equipments on the road or some garbage place, sometimes they will get blasted as well. So you have to dispose of them with the proper care, because all these devices will have certain equipments which are susceptible to blasting out. Discard or used unwanted electrical equipments in a convenient and environment responsible manner. See, basically you and me might not be knowing the proper way of disposing it, but there are certain companies who are specialized in disposing e-waste. So as an organization, you better connect with those organizations, and as per their guidelines, you just hand it over all those e-waste. Okay, they will take care of a proper way of recycling it. Yeah, this is what I was saying. Even recycle computers through manufacturers who have the recycling services. So because if you are using a particular company branded products, that company might be having all those process how to recycle them. They know it. So better you hand it over to them. They will reprocess it without damaging any environment. So this is what they're saying. Now, make environment friendly purchase decisions. Means, let's say on your purchase policy also, try to implement as much as possible in procuring the environment friendly products. Let's say when you are buying any electronic equipments, if your purchase policy says you need to buy the 5-star rated products, students, I think you might be knowing it. 4-star. 1 minute, students. Sorry. So whenever you are buying some electronic equipments, I think I captured somewhere here. So on those electronic equipments, you have 4-star rated, 5-star rated, 3-star rated. What does that mean? The electricity consumption. If you buy a 5-star rated electric equipment, it won't consume a high amount of electricity. So ultimately, it saves the cost. It also saves the energy, right? Instead of using 5 units a day, if it takes only 2 units, you are saving 3 units cost, as well as the 3 units can be utilized by somebody else. So the production of 3 units is reduced, right? Ultimately, the natural resources are saved. So in your purchase policy also have these kind of things. Whenever an organization has to procure an electrical equipment, always buy a 5-star rated product, something like this. And also, if you are designing any product, set the performance criteria. It should ensure that they should have a 5-star rated product. If you are producing, if you are on the production side, ensure that try to produce, you should have certain performance criteria. Unless it meets that criteria, you should not sell it to the customers. Reduce packaging materials. Nowadays, you and me can see, let's say if you order some product on Myntra, I am recently seeing it. So they are not delivering on a plastic cover. They are always delivering using a paper. That paper can be easily recycled. If not recycled, even you throw it out on the garbage, that doesn't damage the earth because it can get recycled automatically. So reduce the packaging materials. Use server storage virtualization. As I said in the previous example, instead of buying multiple servers, try to use the virtualization where one server can be used for multiple purpose. So how you're helping the environment here? Instead of using, see, when you're not buying multiple servers, that means power have been reduced, power consumption. If you're having multiple servers, multiple power cables will be there and multiple power consumption will be there, that have been reduced. And also to prepare a CPU, to produce a CPU, they'll be using a lot of plastic and electrical related components or chemicals, right? All those have been saved. From your point of view, at least you reduce buying multiple things. So this is what they're saying. On your purchase policy, try to build in as much as possible environment friendly decisions and reduce paper consumption. As I already talked about in the start, don't print it unless it is needed. Try to print on both the sides. Try to use only blacking, something like this. So all these things can be implemented in the organization. Again, one more thing. Usually what happens, there is a machine called shredder. So what happens when there are a lot of printouts we take in the organization for various purposes. When that purpose is met, all those papers will be lying on your table or some part of the office. So what you can do, even from security perspective, it is better not to keep those papers available on the table openly. So somebody can leak that information to a competitor, anything can happen. So once your purpose is done, there is a machine called shredders. So usually what happens, all those unnecessary papers which we printed, we put it in that machine that will cut the paper bits and pieces, small pieces it will cut. So security perspective, nobody can read through it, what is there in the content. And also what organization does, all those bits and pieces of paper, they will send it to recyclers, either for a money or a free of cost as part of corporate social responsibility activity. So they can use that paper shredders as small pieces of the paper and recycle it and produce a fresh paper. So you could have asked, instead of doing all those stuff, you could have directly given the paper. But if you give a direct paper, it's a high risk that your organization related data can be seen by somebody else. So these are the couple of policies you can implement. Conserve energy. Again, wherever possible, use LED lights instead of normal lights. Use the LCD. See, they are talking about LCD. Nowadays, if you see, you have LED, OLED, QLED. A lot of technologies are evolved in the screen. So use better technologies which consumes less power and doesn't impact the person who is using it. And also develop think client strategy. That means all the desks to the employees, you give think client, means they don't have much processing capacity. If they want high, they will use from the server, so that you can avoid buying multiple CPUs with a high storage capacity or a high processing capacity. All these things can be used from a common server. So this is what think client strategy. Power management feature. You can instruct your employees, or you can put in your systems itself, all the laptops or desktops you give to employees. you can set up the options on the power management. If that system is not in use for 10 minutes or 15 minutes, it will automatically goes to sleep mode so that the battery have been saved. If the battery is saved, you need not recharge it. You need not put a power cable to recharge it again. So with that, you're saving the battery as well. So a lot of benefits as well. Power down the equipment during extended period of inactivity. Let's say if a particular system is not in use for a longer period of time, better to switch it off so that at least power can be saved. And also use devices that can perform more than one task. They're talking about multi-purpose printer. That means if you see nowadays, the same device can do scan, print, Xerox. So 3-in-1, right? If you buy one machine for this, one machine for this, one machine for this, you end up having 3 machines, which requires 3 power source cables and higher power consumption. Instead of that, you buy a single machine which can do all the job. And employ alternative energy sources. Instead of using regular power, try to use solar power. These kind of things will help you to reduce the natural risk. Means solar, the input doesn't bother, right? We are not generating it by destroying anything. So we are taking it from sun and reusing it. So alternative energy resources like wind energy, wherever possible, you deploy those kind of energy sources. So if you see all these things, all they're talking about, ensure you are not damaging the environment. Try to utilize the resources very carefully. That's what the summary of green computing. Now on the security and the challenges part, theoretically it is all good, but sometimes certain challenges will be there to the organization. What they're saying, evaluate the actual security mechanisms in order to assess their energy consumption. It's not easy for you to assess the power consumption and then take a call. Just because you say, hey, this machine is consuming 10 units per day, so better not to use it. So you can't simply take a decision like that. Evaluate whether this machine, how important this machine is, or can you use any alternative methods instead of this machine? You can use any other machine. Is there any other machine available in the market? So to assess and take a decision is not that easy in all the areas. And also building new security mechanisms by considering the energy cost from the design phase. So you remember, students, when we talked about here, set performance criteria for the design of the product. When you're designing a product, ensure that this product takes the least amount required. If you remember, in previous days when you're using mobile phones, the batteries are not giving that great battery. Nowadays, a lot of China-based mobiles or even a lot of electronic devices are coming with improved battery performance, which gives 10 days or a 15 days battery. Even though the size is very small, they gives a life of 10 days or 15 days instead of daily recharge. So this is what they're saying here. When you're designing the product, set the performance criteria so that you can better design. Ultimately, when the battery backup is more, I'm not consuming it on daily basis. So indirectly, I'm helping the environment. So this is what they're saying. So to bring these kind of things is not that easy, but try to implement as much as possible is what they're saying here. So this is about green computing. Let me see if you have any questions. I am seeing a couple of questions here. Yes, Surbi, as you said, many places nowadays, those sensor lights, if the machine is, if there is nobody, automatically it will get switched off. Yes, that is also one of the mechanism of green computing. Correct. True. When so 90% prints on office are useless and remaining 10% is our notes. Yes, so basically we have to avoid, just because you are able to print out free of cost, many people tend to print for no reason. So this is what. So you please give those awareness to the persons who are printing unnecessarily. It's not that the paper cost, you are damaging the environmental resources as well. Surabhi, yes, 5-star electrical appliances is one of the example. Pooja. So she was giving a note during my school days, or rather in pre-COVID period, we used it to like being explained by using our color chalk pieces, but it was very rare. But now thanks to the technology, because we are attending with attractive PPs and note with colors we wish. Absolutely, Pooja. So as you are seeing now, I'm using a digital tablet where I can write, so it doesn't destroy in any way the natures. True. What is the track change feature in electronic document? What is this, Hiral? Are you talking about? Hiral, if you can give me which page or which paragraph, what is track change feature in electronic document? I'm not sure about this. Give me more context to it. Surabhi is saying Indians know very well how to use the things until it becomes useless. So as there is so much of waste in countries like India, why is it so? You're seeing on one side to it, Surabhi, but of course, if you see the current generation, I'll give you, definitely you can answer it. In previous days, how many days a mobile device have been used by our parents? Still, my mother is using the same phone from last so many years. Okay, in spite of the fact that I said, okay, let's go on to a new mobile. The only statement she says, it is working fine for me. I don't need any new mobile. Whereas our generation, we use example Apple 13 in this year. The next year, Apple releases Apple 14. Then I discard this phone. I go for a new phone. So why we're going with this? That is our mindset. So our generation, even if a small problem happens in any electronic device, the only option we look for is buying a new one. Very less people go for repair. So that's how our generation is growing. So that actually leads to this unnecessary wastage. Sonika, see, all these comments are being reviewed by Board of Studies as well. Don't worry, they will share the schedule of LCC batch 5 for the month of May and upcoming months as well. Okay, they'll be reviewing all these queries along with me. Okay, here we will see that question. Let me finish this, then we will see that. Let's have a quick assessment on this, then we will move on to the next part. Green computing, students, please share your responses to this. We need to rush a little bit. So first question, the answer is D. For second question, answer is A. Hitesh, you have given a right answer. Himanshu have given a right answer. Good. So let's go on to the next topic. Bring your own device. In short form, they call it as BYOD. Again, this is also not a technology, it's just a concept similar to green computing. So in simple terms, what is this concept means? In organizations, let's say to perform my job, I need definitely a laptop or a desktop, and also to communicate with my colleagues or for any purposes, maybe I might require my mobile phone as well. As these are very common in nature, I'm just took these as example. In these cases, instead of organizations giving a laptop or mobile phone for your office purposes, if they say, hey, why can't you use your own devices? So that's called bring your own device. If you see here, it's a business policy. Again, it's not a technology. It's not a technology that allows employees to use their preferred computing devices like smartphones and laptops for business purposes. So they are using their own personal laptops or mobile devices for business purposes. If the company allows that, that's called BYOD. So it means employees are welcome to use their personal devices to connect to the corporate network to access information and application. So I think you understand conceptually what is meant by BYOD. Now let us see the advantages and risk here. What is the advantage? Happy employees. Why? Because, example, in my case, I spent a good amount of amount and bought an excellent, maybe a MacBook. I was very much interested to use my MacBook. But offices, they don't spend huge amount on those devices, right? For them, performance is required. The job getting done is required. So they would have bought some low-end devices which you are not much comfortable, or maybe you are a kind of person who are very accustomed to use the Apple MacBook and you find bit difficult to use the other operating system devices, or the vice versa. So as you are very comfortable using your own laptop, if organizations allow them to use your own laptop, you will be definitely happy. You need not manage two devices. and I see many salespeople struggle to use two laptops or two mobile devices. I'm sorry, students, I'm getting some random calls. So happy employees, how they become happy? Because they're allowed to use their own devices, so they need not carry two devices. Lower IT budgets, of course, as organizations need not spend on buying new devices, they can save their cost. Reduced IT support requirement, because if it is an organization laptop or a mobile device, if it is not working, organization should have their own IT team to take care of all these things. Now, as they allowed to use your own systems, if any issue comes, you have to sort it out. Organizations, see, they might reimburse the amount and all, if at all, if that is not working as per the policy, but they need not maintain an IT team to fix all the issues what you are facing in your laptops or mobile devices. Early adoption of new technologies. Why? Because as you're already accustomed to your laptop or a mobile device, so you can easily start working onto it. If they have given a new device, then it will be a bit difficult. Example, so far from the day I started using the laptops or desktops, I'm very much comfortable in Windows operating system. And also from my mobile perspective, I'm more comfortable in Android operating system. Now I joined in an organization where they use only Apple products. They have given an Apple MacBook and Apple mobile phone to me. So it gives an excitement. Hey, I'm using Apple products, but their Apple product work completely in a different way. I should spend a lot of time to understand how a certain key works in a laptop, how a certain application works in Apple device. So adoption of new technologies is a bit difficult, but if they allow me to use my own devices, then I can be quickly adopt because I know already how to use them. So this is what the advantages part. Increased employee efficiency, as more efficient in using own devices, no additional learning required. This is what I'm saying. So it increases the employee efficiency. So these are the advantages of bring your own device. From the risks perspective, network risk. What they're saying, lack of device visibility. What does that mean? Let's say if organization has given a laptop, they can identify that laptop with a MAC address. How you identify a system on the network with an IP address? For every physical device, there will be a MAC address. Similarly, how you will have IMEI number for your mobile phone, laptops also have a MAC address through which they can identify the hardware. Now, if they implement this bring your own device concept, today I take one laptop and connect it to my office network. Tomorrow I can take another laptop and connect it to my office network. So they can't establish whether this person who is logging into my network is the right person or not, because every time the device IDs can change. There is no guarantee that I use the same laptop. When you allow me to use my personal laptop, if I have multiple laptops, I can use multiple laptops every time I connect with a new device. So that is a bit risky to know and restrict that whether this device is a genuine device or not. Then the second thing is device risk. Loss of devices. That means, let's assume they allowed me to use my own laptop and also my own mobile device. So all the organization data somehow is being stored on my device, because when I'm working with them, certain data might get stored. Example, if I am using my office mail on my mobile device, if I lost my mobile device, whoever got access to my mobile device, they can also see my office data. So there is a risk of device. Then the application risk. They're talking about viruses and malware. I can understand how many of us are using the licensed antiviruses. Many people are least bothered, or many people might be using the cracked version of antivirus, which will not give you 100% protection. So if organizations allow to use your own devices, which are not that secured, so ultimately keeping the organization data at risk. So that is called application risk. Finally, implementation risk. So they should have very clear-cut guidelines when they allow to use your personal devices. If they have a weak policy, that will eventually impact the organization, especially because the organization data is at risk. Okay, so these are all the risks in BYOD. It's okay. I'm just skipping this assessment because we need to understand that concept. So students, any doubts on bring your own device concept? Yeah, I'm seeing last response from Pooja with regards to feature phones. Yeah, there is a question from Pooja. When Office lets us use products given by them, they allow only in Office, or they give it for our personal use also, sir? Yeah. See, it depends on organization to organization, Pooja. Let's say in my career, I have worked in many organizations. Almost all the organizations have given laptops to me to deliver the work, and I use it to bring back to home. But certain laptops, I cannot put any pen drive, so they will be disabling all the pen drives, and I can't even access certain websites or certain applications, so they'll be putting a lot of restrictions to safeguard their device as well as the data. Whereas certain organizations, they are least bothered. They say that we trust our employees, they know how to take care of our data, so they allow everything. So it all depends on the organization, but basically I personally don't encourage to use Office devices for personal use. If something happens, then it won't be good. So this is about the bring your own device. It's a very simple concept, and it's also a policy. It's not a technology. Now we are getting into the interesting one, Web 3.0. So for this, in your syllabus, students, you have Web 3.0, but for your understanding sake, I have brought what is Web 1.0, 2.0. Finally, we are going to discuss about Web 3.0, Web 4.0, 5.0. So predominantly the discussion will be on 3.0, but for you to understand how this is evolving, and especially in current days, students, believe me, Web 3.0 is going to a great technology. A lot of applications are being built on this technology. Now, without much delay, let's discuss on this. So we'll come back to this, but I'm just reading through it. The term Web 3.0, also known as the semantic web, it describes the sites wherein the computers will generate the raw data on their own without user direct intervention. So this is very much important for you to understand what is Web 3.0. So now this statement I will explain with an example. So as I told you, I am taking you from Web 1.0, Web 2.0. These two are not form part of your syllabus. You have to read from Web 3.0 only. Okay. Let us see this. When initially this technology came, so the first phase of stage of the technology is Web 1.0. That means you are using the web. Web means that www dot, all the websites. Okay, in simple terms, you are using only for read-only purpose. So you log into that website, you read the data. You can't communicate, you can't comment on the data. Okay, that's called read-only. It's a one-way communication. If you see here, there is a website, and all you can do is read the data. What is mentioned on the website is called Web 1.0. Example I have given, let's say static website. Our institute website I have given, like if you go to www.ici.org, so that website purpose is to give information or to assimilate information to all the members and students, what is happening in the institute, what is the upcoming plans or events, right? So you will use that website to read the data. This is called Web 1.0. That's what happening in Web 1.0. Whereas the Web 2.0, these technologies or these websites allow you to read and write. You are observing the difference between Web 1.0 and Web 2.0, students. Here you can only read. Here you can read and write. What is the examples? These are very small screens shots I have given here, but I'm writing here. The examples are, let's say, all your social media platforms, be it Facebook, Twitter, or YouTube. Means what you do in those Facebook, you are reading the data, what your friends and families are posted on that, and also you are commenting, you are liking, you are sharing. That means some actions are taken by you on those websites. Okay, that is Web 2.0. Now let us understand Web 3.0. What does that mean? It's not only read and write, it also semantic. Semantic means it become intelligent. The websites become intelligent. How? I have given an example here. If you see, I went to Amazon. Okay. I browsed for certain mobile phone. Let's assume that I browsed on Amazon website certain mobile phones. Now, I closed the Amazon website. I went to a different website. Maybe some news. I want to read some news. I went to that website. I'm opened that website. Students, have you ever observed that lot of product advertisements which you recently searched or which you recently discussed, even with the like if you're talking about our phone, so they would be listening it, and accordingly the related product advertisements are shown on that page. You might be wondering how these website guys knows that I'm talking about some product. Recently I was talking about some insurance product. I want to take it for my family. So when I navigate to this mobile phone, I was searching something else on YouTube. So there I am seeing a insurance related product advertisements. So that means they are listening our voices. Accordingly, they are marketing the products. So as I am talking about insurance, they send the insurance related product. If I'm talking about something else, the related ones are displaying on those websites. So they became intelligent. Whatever we are talking, that means the machine to machine they are communicating. Example, in the browser example, I used my laptop or a desktop on Amazon.in. I searched for mobile devices. Now I am using the same device to read some news, maybe the Deccan Chronicle, the Hindu, or whatever, some national or a local news. I'm reading it. So there I'm seeing the product related advertisements. So how these two websites are talking and showing that information, that's called Web 3.0. We are not only read and write, it has given the intelligence also to those websites. That is what Web 3.0. Now, if you go back and read this definition, you will be able to understand. You see here, wherein the computers will generate the raw data on their own without the user direct intervention. I never said to the computer, hey, I'm looking, means initially I searched those products. Now I closed the website and I opened a new website. But on this website, they are showing the products which I searched, right? But I never talked about to this new newspaper website that I'm looking for a shoes or a mobile phones. So they keep displaying on it. So this is what Web 3.0. So the components of Web 3.0, how it works, it has a semantic web. That means it has an intelligence. So a common framework that could be used to share and reuse the data across various applications, enterprises, and community boundaries. As I said, they use a framework. Framework is not of some kind of software or applications. So using that, they share the data. So that website shared this to this website, so that it basically, I can tell you in simple terms, they use cookies. One of the, you can take this as an example for the framework. So whenever you are browsing it, you will get a message saying that accept cookies or not. The moment you say, you are giving permission to a lot of vendors to read your data, whatever you are searching on the website, you are giving a permission to those cookies to read your data. Based on that, they will recommend that. Example, if I search for mobile phones on a particular website, all the mobile phone related companies will get this information. Hey, this person is looking for mobile phones. So this is what the information. Now they start advertising on my devices or my email ID, wherever they find, they send all those information to me. The another thing is web services. It's a software system that supports computer to computer interaction over the internet. So using these two components, so the Web 3.0 works, means how it became intelligent with the help of the framework and also the web services. Basically, web services means over internet, those two devices will communicate, means the information is from here, it communicates to their server, those shopkeepers servers, and then send back those relevant advertisements to our machine. So these two devices communicate over internet and then send the relevant information. So this is what Web 3.0, and they just talked about Web 4.0 and 5.0. How much becoming, I mean, see, we already amazed with the capacity of Web 3.0, but the story didn't stop it there. The way forward is you are going to get Web 4.0, 5.0, where if you see the Web 5.0, the telepathic web or symbionet web, that means you think in your brain, automatically system understand and opens the related one. Let's say I just think in my mind, hey, I want to shop certain things on Amazon. I just thought, I don't even speak. See, speaking and recognizing is always there as part of machine learning. But I just thought in my brain, how about shopping on Amazon.com? If I'm thinking in my brain, automatically my system understands the thought and opens the Amazon.in or a Flipkart.com, whatever the website or information I'm looking for. So that is what they're saying, Web 5.0, the telepathic web. Whereas the Web 4.0, the intelligent web, as they're saying, if you see autonomous, proactive, content exploring, self-learning, all these are examples of those machine learning or artificial intelligence stuff where they become much more intelligent. Over a period of time, they learn from all the searches and become much intelligent and suggest to us. So these are the way forward on the web technologies. So no worries, I'm just skipping the assessment to save some time. So any doubts on Web 3.0 students? AI, as I told you, Mansha, Web 4.0 is predominantly uses the AI technologies. Even Web 3.0 uses those technologies. So through them only it understands and sends back the data. Okay. Now let's move on to Internet of Things. So in very simple terms, IoT means all your devices are connected to the internet. When I say devices, especially when they talk about things, okay? If you see here, your home is connected, your car is connected, your system is connected, or your washing machine or refrigerator, all those are connected to the internet. How this concept works, I'll give you an example. You can search on YouTube. There are beautiful videos on this IoT technology, how the device works. Even you have a couple of examples to discuss. What does that mean? Let's say I have a certain washing machine in my home. It has to be serviced on a frequent basis. Let's say every 6 months it has to be serviced. Or let's say I have a water purifier. I think you know how a purifier works. It will have a candles inside of it. The filters, basically, the capacity of the filter is for certain number of liters. Maybe for 25,000 liters, you can use these filters. Once you used it, means once you consumed 25,000 liters of water from this RO system, those candles or filters need to be replaced. Usually what happens, you will be monitoring it. How you and me can identify whether the filters need to be replaced or not in a very jugaad way. The water taste will get changed. Then you will understand, hey, maybe the filters are depleted. I need to change. This is one way, right? Instead of that, we all know that it goes by rule. The moment you consume 25,000 liters of water, whether that can be done in 6 months or 1 year or 2 years, whenever the 25,000 liters are consumed, if the device has given an intelligence to give you an alert, automatically it send an SMS to you as well as the RO product guy. Example, if I buy from this product from Purit, where maybe I think you might be seeing that Mr. Sachin Tendulkar keeps as ambassador for that Purit product. So let's say that water or that purifier, it gives an alert to the device manufacturer as well as to the customer. Hey, you consumed 25,000 liters. Now it's time to replace the filters. So this is an example of IoT. Similarly, you see a refrigerator. We all have a refrigerator. Let's assume you keep milk in it. Okay. The moment system scans, your refrigerator has given that intelligence to understand that you are placing milk in this capacity. Whenever the milk is coming down, automatically it places an order to the milk vendor to get 1 more liter of milk. Assume if you have that kind of intelligence in your refrigerator, how beautiful it is. So there are various examples, real time. We are all using a lot of IoT products. So we will just read through the technology now. Hemansh, yes. Alexa, I can say more on machine learning. Yes, it is also one of IoT device. Hitesh Jain, absolutely you bang on. Smartwatches are examples of IoT devices. All these Wi-Fi enabled devices, car connected features. Absolutely. Yeah, even my car, I can control from my mobile phone the engine start or stop, I can do it. And it will give you, if there are any issues or malfunctioning in my car, that will give you an alert to my mobile device. So these are all the examples of IoT devices. So as you all are aware that IoT, what is an IoT? Let's quickly see what is there in your syllabus. So IoT means it's a system of interrelated computing devices, be it mechanical or digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or a human to computer interaction. So as you can see, without human to human, let's say, I will give you an example of one more thing. Nowadays, a lot of people are using these smartwatches, right? You and me might be using for just to have that fanciness, but in real terms, especially for certain people like who are heart patients or some critical devices people, these smartwatches monitor their health conditions. Whenever they identify that the blood pressure of that person is going up or going down, automatically it can send an alert to his doctor to alert the hospital that this person is going beyond the allowed limits. So these kind of things also happen. So instead of, say, let's say one of your family member fall down because of low BP, you need to call to the doctor and say out to the hospital, hey, my family member fall down and can you please take care of it, or you need to find out the ambulance. Instead of that, visualize that you have a smart watch which is put on your wrist, and automatically the moment it falls down below the accepted limit, if it sends an alert to the ambulance or to the hospital, and if the ambulance comes back to the home, how advantageous it is. So these are the technologies we are talking now. So how it works? It embedded with electronics, internet connectivity, and other forms of hardware such as sensors. So these devices can communicate and interact with others over the internet, and then they can remotely monitor and control. As I said, example in that health condition case, the doctors can give these devices to their patients, and all the data they can monitor from their systems at any given point of time. What is the heart rate, or what is the BP rate? And especially, I believe students in COVID times, many of us are concerned about this SpO2 percentage, how much oxygen percentage is there in your blood. So that is one of the critical metric to evaluate the criticality of COVID, right? So even those things can be measured on these devices. So the goal, what is the goal? To make these devices communicate with each other, and therefore it become more intelligent and independent. So instead of you telling to the doctor that, hey, I'm having some, like certain issues on my body, the devices can automatically communicate to your doctor. So if you see here, they uses the artificial intelligence and machine learning technologies to do that. Couple of examples they're given here. So these are the couple of applications of IoT. I will leave it to the students. You can read through these examples. I have also given couple of practical cases. Example, resource utilization tracking by government. So the dustbins example, what they're saying, let's say the dustbin are given certain sensors. Usually many times what we see, even though those dustbins are filled and falling down all the dust surrounding the dustbin, the municipal people will come in their own time and finally take the dust, right? So instead of that, if these dustbins are filled with the sensor, the moment it reaches the top layer of the dustbin, automatically it sends alert to the municipal department and also to all the higher authorities. If that information is being displayed on the screen, so everybody in the department will know that, hey, there is in one locality, the dustbin is filled and we have to go and take it. If they didn't take it, it keeps alarm. It keeps giving an alarm so that at least with fear, they will go and take it. So these are the various examples of IoT. Here you can just quickly read through these examples. You'll be able to understand. Example, that smart retail, Amazon Go. Students search on YouTube how the Amazon Go web shop will work. Nowadays, I think many shops are coming in that context. You need not do anything. You go to a shop, select the item, you just simply walk away. Automatically, the payment will get deducted from your banking partner. So how it works, you can just see that the technology, how all these Amazon means all these kind of outlets are enabled with IoT. All the products you take, it will get added to the cart. If I put it back one of the item from your basket, that will reduce it from your cart. So I kindly request you to read through this, view this video on Amazon about Amazon Go. So These are the various applications of IoT. I was not reading through it. These are just examples of the technology. So what are all the risks of IoT? We understand how good these technologies help, but the risks is out of business. Example, if you are not adopting to these new technologies, if your products are not having these technologies, you will be out of the race. So similarly, how we have seen in mobile industry, Nokia is unable to compete with the technology. So they gone out of business. So they are doing extremely well in mobile industry initial days, but with the advent of smartphones, for some reason, they are not able to cope up with the competition. They've gone out of business. Similarly, if you are producing a washing machine, let's say forget about cars only. Let's take the automobile industry. In India, with the advent of the Kia Motors, so they brought a lot of technological features in their cars. Now, let's take any other brands which have been in India from so far, like a Hyundai or a Maruti. If in their cars, if you don't have all these features, customers will like this generation people are not that keen. Hey, these are very old models. See these cars, how I can control with my mobile or my smartwatch. So definitely you will get a competitive advantage. The another risk is data storage and analytics, because especially as you're communicating your customers' data with your customers' data, it is ultimate responsibility is you to safeguard the data securely so that it will not fall trap. Then intentional obsolescence of devices. What happens? Let's say you bought a certain device with a IoT capability, all those stuff. For some reason, the companies discontinued that product, or they gone out of business. So all those supported features will not work because there is nobody to support on those advanced features. So sometimes this is what happens with this obsolescence of devices. So you or they may say, this is how my previous product used to work. If you want to enjoy these new features, you have to discard, you have to mandatorily upgrade your old device to new device. So maybe you can recollect with a couple of mobile phones, especially on a Samsung, all those things. So until certain period of time, they will give the OS updates. After some point of time, for those models, they will not give you. So what happens? Since those operating system have some bugs or some issues, if they are not giving fixes for you, ultimately you need to discard that phone and buy a new phone with the latest operating system. So that is how the issues of the manufacturers. Then risks to users of this product, of course, on the data part, as you are sharing your personal information, always the risk is there. Privacy, autonomy, and control, of course. Technology risk, because there are no standards to be followed for these kind of products. So you should be little careful in using all these devices. You are not sure how this data have been used. Maybe let's assume we're talking about that smartwatch, right? If that health information is shared to the health insurance service providers, whenever you are going for a policy, they can read this information. Even though you say you don't have a BP, they can come to know that, hey, you are using, like we got to know that you have a low BP. So we should be very careful in using all these IoT devices. And of course, environmental risk, especially since all these involves electronics. To produce these electronic devices, you will be using certain natural resources. So it will lead to the environmental risks as well. So I'm against skipping this assessment question. Definitely you can go through it. So this is what IoT. Let me see if there are any doubts. Ayush, yes, FASTag is also one good example for IoT. For students who are not aware about FASTag, especially if your vehicle is going on the highways, national highways, you need to pay toll charges, right? There will be a toll gate where they will be collecting certain fees for using that road. So the government of India brought a FASTag. It's a RFID, radio frequency identification tag, which will be there on the car. So now when the toll gate approaches, you can simply go. You need not stop, pay the change, or take the receipt and all those stuff. So automatically there will be some sensors placed on the toll gate. When your vehicle passes, it reads from your card. That card has to be loaded with the balance. So if that balance is there, it will allow you, the gate will open automatically. If there is no balance, the gate will not open. right? So fast tag is also one example of IoT. Correct, Hitesh, Wi-Fi enabled ACs, washing machines, all these are all examples of IoT. Correct. Let's go on to the rest of the topics. Artificial intelligence. See, as the name suggests, artificial intelligence, we know what is meant by intelligence, right? So you remember that data, information, knowledge, intelligent, how it converts. Similarly, if the same activity is exhibited by machines, it's called artificial intelligence. This is what they're saying. The ability to use memory, knowledge, your experience and understanding, reasoning, imagination, all the skill sets to solve the problems and adapt to new situations is called intelligence. If that skill set is exhibited by machines, it's called artificial intelligence, because usually humans are only having that intelligence part. If the same intelligence is displayed or showed by machines, it becomes artificial intelligence. Examples, they're talking about autonomous vehicles, Tesla car, online assistant, Apple Siri. Let's say if you ask something Apple Siri, it will go and check. Let's say, hey Siri, what is the temperature today? If I ask this question to Apple Siri, then it will automatically go and check over the internet and find the weather report and says that information to you. So how that intelligence is built, that is with the help of artificial intelligence. So basically, this is the subset of the subset of that is a machine learning. With that, these technologies works. So if you see, again, these are also various examples of artificial intelligence. We can discuss one or two, but these are all just examples. You can read through it. Autonomous vehicles such as drones or self-driving cars. So in India, still I think Tesla is not into picture. Tesla is famous for this self-autonomous, means you need not drive that vehicle. You enter into the car, you give from destination and enter the to destination on the map on the car. Automatically, the car takes you. You can sit comfortably on the backside of the car and enjoy and relax. You can be relaxed. So that is what the self-driving cars. A lot of videos are available, students. You can see on the internet to understand how these are in real use. So even that creating art. Okay, I want to give you this example. Let's say maybe after this session, you can see on Grammarly, that application you can install on your system as well. Whenever you are writing emails or any Word documents, it will read through the data and suggest the grammatical errors to be fixed. So how that intelligence has given to that product, that is again a subset of artificial intelligence. That intelligence has been built in the product with the help of a lot of rules, so that whenever somebody is writing, it can read it and apply the grammatical rules and suggest that, hey, you are putting a wrong word, so please correct it. So these are all the examples of the artificial intelligence. So a couple of examples are there, students, here. You can just read through it. So what are all the risks and controls in AI? Again, it relies heavily on data. So if the data itself is wrong, it leads to incorrect decision. So the risk is the data accuracy, and it carries security threats. I can tell you an example. I think the movie name is I, Robot 2020. So in that movie, what happens? They talked about in 2020 how the world will be, because they created this movie sometime in I think means when we are in 1990s or 2000 earlys. So they created this movie. The moral of the movie: entire works are taken care by the robots by 2020, because you'll not be having any maid, you will not be having any security people. Lot of works are done by robots itself. But what happens? One of the robot got that intelligence and wants to dominate all the humans, because humans doesn't know how to take care of it. So because of that, the robot wants to take care of all, means wants to take the control to manage the humans. So basically, we created robots to help us, not to control us. So in that movie, how finally the hero sorted out that issue is what that movie. This is what they're saying. Some of the AI products, sometimes what happens, if you give that intelligence to those machines, sometimes it may go beyond the human control and kill the humans as well. So the risk is you need to have a kill button, so that if it is going beyond your control, if you just click that kill button, it should collapse the entire device. So that option should be there. That's what a lot of countries are suggesting now. For any AI product, you should have a kill button, so that if it is going beyond our control, you can switch it off. And also, as lot of intelligence works are taken care by them, it might kill human skills of thinking. So if you just recollect the calculator, in those days where you don't have a calculator, our parents or grandparents, they used it to calculate manually or with the help of pen and paper, max to max. But nowadays, even a simple calculation, many of us use our mobile phone calculator and find out. So we ourselves decreasing the human capabilities because we are dependent heavily on these devices. And also, how many times you say these are advanced, definitely they can't think out of the box, because all these things works as per the rules we have designed. So if anything comes that out of that rule, it definitely will not be able to think as good as a human. So that's why students, these technologies are good, lot of benefits are there, but they will never replace humans is what the belief, right? So that's what they're saying. And especially on the controls part, extremely complex, because the nature of processing is very complex on these technologies. So this is what the artificial intelligence means. Again, students, I'm just skipping these assessment questions. You can go through it once you are doing it. On machine learning, so I would like to show this diagram. This is how these are all connected, students. Artificial intelligence is the broader term. If you see here, programs with the ability to learn and reason like humans. In this artificial intelligence, machine learning is subset of it, okay? Where focus is basically on the machines part. Again, there is one more subset, is called deep learning, where it talk about natural language processing, NLP, natural understanding. So a couple of technologies are there. This is how all these technologies are interrelated. If somebody talk about machine learning, it is basically a component of artificial intelligence only. So machine learning is the learning in which machine can learn by its own without being explicitly programmed. So that Apple Siri or Google Mini, Amazon Alexa, all these are examples of machine learning, where a lot of times they train the devices. Like, let's say if you ask a question, hey, what is the weather now? How that electronic device understand you are asking about weather? They train with a lot of times. If somebody asks this question, whether you have to do this way. So they train lot of questions. They keep improvising it. You might be noticing that for certain questions, it will not have an answer. What the device manufacturers does, all your questions data will be sent to the manufacturers. You have to give consent when you're signing up. So you see that there is a condition. All this data can be given to the manufacturers for their analysis. So they will see, hey, these are all the questions asked by the humans. And for these are all the questions, these are all the answers given by the devices. So they will identify the accuracy. If they want to improve for any of the questions, they still improvise means they will train those machines and release the next versions or updates to those existing devices. So that is how they train the machines so that they can understand and respond. So this is part of artificial intelligence thing. So again, they are given the examples of Apple Siri and autonomous vehicles only here. Now, the last topic is blockchain. This is somewhat new to you guys. You will not be maybe exposed to this technology yet. Before I get into it, let me see the questions here. Anything here? Fingerprint sensor is an example of AI. It's a kind of IoT device. Again, IoT uses the artificial intelligence and machine learning. Hitesh, Google Assistant. Yes, Google Assistant is an example of AI. Correct. Now, we're in the last topic for today, blockchain. I will take you an example with the blockchain because I want to explain you this. I'll take a couple of minutes to explain you. Let's say for you to understand, there are 4 people in the place, A, B, C, D. Okay. Everybody have certain money with them. let's assume that they'll have 100, 200, 300, 400. How to be sure that this person is having 100? Okay, I will give you a scenario. What they're saying, they are using a common book. If A says I have 100, that transaction has to be reviewed and accepted by B, C, D. Okay, A says that I have 100 rupees with me. Then the transaction will be reviewed and accepted by B, C, D. Now, everybody knows that. Means apart from A, B knows that A have 100. C also knows that A have 100. D knows that A have 100. Okay. Now, similarly, B says I have 200. C says I have 300. D says I have 400. And all these things are reviewed and accepted by other people. Here, the second transaction is reviewed and accepted by ACD. The third transaction is accepted by BAD. The fourth transaction is accepted by ABC. After this exercise happens, what is the situation? Everybody knows that what is the exact amount the other person holds, right? Now, if A want to transfer funds to B, 200 rupees. A says that, hey B, I am transferring 200 rupees. Is that possible? Students, with that example, can you just respond? If A says, I'm going to transfer 200 rupees. Is that transaction possible? Is that B accepts that the 200? Students, please respond. Please share your responses. So this example clarifies the entire concept of blockchain technology. That's the reason. Follow this example, then it will be easy, very easy for you to understand the technology and also the underlying terms. I'm waiting for your responses, students. Himanshu said no. Karthik, not possible. No, no, no. How you are all saying that? No, because all are using one ledger where the control is by everybody. He can't simply mislead the system saying that I have 200, because when you initially said 100, it is reviewed and accepted by BCD, right? Similarly, everybody is reviewed. Now, he can transfer only 100 or less than 100. Let's assume he transferred 70 rupees to B. Now, the moment this transaction happens, it will be updated to C, it will be updated to D. Anyway, B also knows that. What happens after this? This same ledger will be updated now. A is having 100 minus 70, so he will be having 30. So it is acknowledged by B, C, D. Now B says, I have 200 plus 70, 270. This will be acknowledged by A, C, D. Now, similarly, C will be having 300, D will be having 400. There are no transactions, so this is how the transaction happens. Now, tomorrow, what is the latest status? A is having 30, B is having 270, these guys having 300, 400. Next, if anybody is transferring one more time, similarly, every time, so the entire ledger will get updated and the copy is there with everybody. So the latest copy will be there with B, C, D, so that nobody can mislead the system saying that without having something, you can't claim it. And the moment you perform a transaction, let's assume you did this 70 rupee fund transfer and finally funds deducted from here and transferred to the other person, right? So tomorrow you can't come and say, no, I want to cancel the transaction, because already they have been updated to all the books. The transaction is there. You can't reverse it. What all you can do? You might ask B, hey, instead of 70, I was supposed to send 50. Can you transfer back 20 to me? So again, he has to create a fresh transaction. When he did that, again, this book will get updated and everybody will have a copy of the transactions. So at any given point of time, misleading this system is very difficult because the data is distributed to all the peers. So in that technology, in that network, A is a peer, B is also a peer, C is also a peer. These are all called peers or nodes on the network. So where it happens, all this it happens on a network. All these transactions happens on the network. Just stay there with this example. Now we can quickly see the definition here. Blockchain, sometimes referred to as a distributed ledger technology. So if you see here, this ledger copy, this is a ledger copy, is a distributed. The copy is there with A, B, C, D. If any transaction happens, the copy is updated with every transaction. Example, now if you see here, the fund transfer happened between A and B, but still the ledger copy which C has, D has also get updated. Even though the transaction is between A and B, the ledger copy, because always it has to say what the A has, B has, C has, D has. So the funds details get updated with C as well as D, so that C and D also knows what is the correct status of funds with A and B, even though they are not form part of the transaction. That is how the technology works. So if you read this, sometimes referred to as distributed the ledger technology is a shared, the same ledger data shared to all the participants, peer-to-peer. That ABCD is called peers. In the decentralized open ledger of transaction system with no trusted parties in between. If you see this, there is no intermediary here called X who says that there is no such person called X who says that A is correct or B is correct or C is correct or D is correct. The network itself confirms that what is the correct balance A has, what is the correct balance B has or a C has or a D has at any given point of time, because every peer are having the copy of the book, they know what is the correct status. So this is called a blockchain network. Students, believe me, to explain you this concept, we can take an hour or even 2 hours just to make you understand the fundamentals of it. So I have taken the very crisp of the example and given this. Hopefully you understand what is this distributed ledger technology. Now let me continue with the rest of the definition. All transactions are fully irreversible. Why? Because the moment you did a transaction, it goes to all the parties in the network. See, in this example, I have given only 4 parties. In real time, on blockchain technology, on the network, there could be 1 lakh users. If one person does a transaction, the remaining 99,999 users will also get the transaction information. That's how the blockchain technology works. So that's the reason when you perform a transaction, you can't reverse it. What you can do, you can create a fresh transaction to nullify it. The previously executed transaction, you cannot reverse it. And this is a network which is not controlled by any bank or a corporation or government. So that network is not controlled by anybody. It is basically all the users who are connected to that network are controlled. So they themselves control the network. There is no centralized person, no centralized organization. So basically a blockchain generally uses a chain of blocks with each block representing the digital information stored in public database. Now what happens? I'm talking about that transactions, right? In real time, how it happens, let's say at any given point of time, now A has performed certain transaction to B, C has done certain transaction to A, D has done some transaction to B. In this time limit, all these transactions are kept in a data packet, and there is a header and there is a footer for this. All this data will be encrypted and then will be added to the network. This is how it goes. Okay, there will be a block which have all this data. After some time, one more person has done some more transaction. It will be added to another block. Again, the data here. So again, one more block, the data here. So that's the reason they call blockchain. All the blocks are interlinked and it looks like a chain. So what is the content of the block? Basically all the transactions what we talked about. So A would have transferred certain funds to B. All those transactions are kept and added to the block. So the moment the block has been added, that means you are conforming to the network that A has done this transaction, C has done this transaction, D has done this transaction. After this, these are all their balances. So once it is added to this network, nobody can say that, hey, that was a by mistake. Now I want to remodify the amount or remodify the values. No. So that is, once it is done, it's a done. But it has to be reviewed and confirmed. So as I said in this example, if A says I'm transferring 200, you can't, means B knows how much A has, C knows how much A has. So you can't you can't do a malicious transaction on the network, because everybody knows what you have. But you might get a doubt, sir, if everybody knows how much money I have, that's a privacy risk. Yeah, that's where the cryptography comes into picture. Here A means A will be identified with a hash key. Hashing algorithms using a private and public key. Using a private and public key, they will be identified. So you will not be given your original identification. There is some 26 characters identification, something like if somebody, see, you have Aadhaar number, right? Similarly, when you join this blockchain network, you will be given a public key which have some 26 letter alphanumeric number. I don't remember the exact length of it. So that's how you will be identified in the network. They never know who is the original person behind it. Okay. So this is what the blockchain. So what are all the areas this have been used? They have given here. So actually the good thing about blockchain is it's not necessarily mean that only for financial transactions you can use it. I can give you a couple of examples here. Let's say government or a travel industry. Let's take the examples to understand the usage of blockchain. Don't fall in trap that these have been used only for finance transactions. Nowadays, take about this ICI. If our ICI has given the mark sheets and also the membership certificate, right? If you want to authenticate yourself, I am a member of ICAI, you might be giving this membership certificate to one of the required institute or some other place where you need to prove that you are a member of ICAI. Okay. So what they can do, they can see the mark sheet or that membership certificate. But what is the guarantee that the membership certificate is genuine? There is always a risk that, right, nowadays we know how many university certificates can be created as a duplicate or a false certificates. So how to avoid this? There is this blockchain technology can be used. Let's say you qualified CA, your details, your certificate have been placed on blockchain network, which is owned and managed by ICI only. Again, even blockchain also you have private blockchain, public blockchain. Similar to private cloud, public cloud, you also have private and public blockchains where the mark sheet can be placed there and it will be authenticated by the institute. Then only the certificate will be put it on the network. Okay. Now, from then onwards, if you want to submit this mark sheet, you need not submit the physical copy. You can share the link of that certificate. Anybody can go and check that certificate, whether it is a genuine certificate or not, through online by connecting to that network. So that solves the problem of that any submitting multiple times or any false document submission. All those things can be eliminated with the help of blockchain. Students, forget about subject. This is a very interesting and fascinating technology. I would urge you to read a lot of use cases, what is happening on this platform. Couple of things are given in your syllabus. You can definitely read through a lot of use cases in real time, how this technology have been used. So what are all the risks in blockchain? So of course, again, not as you see in that example, A, B, C, D is there, right? So you need to ensure that all the participants also have the same risk appetite or risk tolerances. So C says that, no, I don't understand all this technology. I don't want to form part of this technology. So in that cases, you can't implement the blockchain technology. If you have less participants, they can collide together and malfunction the system. So you need to have more users so that the security on the system will become more. Reliability of financial transactions. So this is what I'm saying, that consensus mechanism means, as I said, when A performs the transaction, B, C, D has to confirm that this is a correct transaction. If B, C, D has come together and says that even though the transaction is genuine, if they all come together and reject it, then the entire system will not work. So that's the reason I'm saying the typical Bitcoin network, that cryptocurrencies. So actually cryptocurrencies are built on top of this blockchain technology. So why the Bitcoin has become so popular? You have so many users on that network. So you can't simply do any false transactions. You can't manage those hundreds and lakhs of users on the network, right? So that's why on any blockchain network to be successful, especially on the public blockchain, if you have more users connected to the network, then it becomes more secure. And absence of any central authority, one side we said it's a positive side. The negative side is, as there is no central authority, so it will be difficult to administer and enforce any protocols or any amendments, any means who actually guides the network if something happens. So those are all the risks. And also on the data part, there is a huge data. Let's say if the transaction is done between A and B, you are broadcasting the transaction across the remaining 99,000 users on the network, right? Unnecessarily, they are also keeping the track of the record, even though they are not at all related to A and B. So there is a huge data that gets piled up, but the advantage is, just as the context came, nowadays the storage cost is becoming much and much cheaper. In previous days, to have 1 GB memory stick, how much it used to cost, nowadays you are getting 1 TB of pen drives also with a very economical cost. So as the storage cost is becoming lesser, people are okay to save huge data or redundant data, considering the advantages it gives. So that's what the blockchain technology. So a couple of controls that can be used, as it has a tremendous high volume of transactions. You need to use the computerized or continuous monitoring techniques to manage these systems. And lot of analytical procedures or data analytics softwares you need to use to analyze this data and predict. And also the communication methods. So as I said, as all people are connected to this network, you need to ensure that these communication methods should be developed to ensure that operational changes are communicated to appropriate personnel. So if any new person is joined, how we ensure that he can dependent on the network, how you ensure that the communications are happening secured without tampering. So these things should be taken care, especially when you are on public domains. So the unique aspects of blockchain, like the consensus mechanism, smart contracts, private keys, the cryptography. So from the audit perspective also, you should be understand how these methodologies work before you audit and vouch the companies which use the blockchain technology. And both internal and external auditors, they shall be engaged in discussions during the development or identification of the blockchain. As I said, as this is a new technology, first and foremost, you need to understand how this technology works so that you can assess the risks associated with it, and then finally take a call whether to implement this technology or not. Still, this technology is in evolving. A lot of companies are start using it, but I see a huge potential in this technology going forward. So I urge all of you to read through about this technology. A lot of articles are available on Google to understand how the blockchain is essentially used in financial and other industries. Cryptocurrency is a bit different. As I said, using the blockchain, so it's called a mining. Let's say, now if you see in this example, when the transaction is performed between A and B, what is the incentive to C and D to confirm that the transaction is correct? Okay, so basically on a network, when I say on the internet network, when all these transactions between the people are happening, there will be a few set of people called miners. Okay, what is their job? They create a block. Okay, in the given point of time, all the transactions performed on the network are available. They called unspent transactions. From the pool, they pick certain transactions and create a block and confirm that these transactions are correct. So I'm giving the simple plain definition, but technologically how they validate is a different topic to discuss. So in order to do that activity, validating the transactions and adding to the blockchain, they will be getting cryptocurrencies. This is called through mining. That activity is called mining. As they did mining of block, they will be rewarded with cryptocurrencies. Okay, the currency which is generated by mining. So that's how the miners get the bitcoins. Okay, and these bitcoins, they can be sold in the secondary market and they can get the money. That is what the cryptocurrencies happens. Mansa, I think I'm not sure whether you are the student who asked last time, non-fungible tokens, NFT. So these are also a blockchain concept. Actually, how when we talk about ERP, you have Oracle, SAP, a different product. Similarly, when I talk about blockchain, this Bitcoins is one of the product which uses blockchain technology. NFT is also one of the product that uses blockchain technology. Non-fungible tokens, basically, they comes into picture when you, let's say you have a book, okay? You authored a book, you want to sell to public. What happens? You put your soft copy on a blockchain technology and you can sell it as a tickets. Non-fungible tokens is nothing but a tickets in simple terms. So whoever bought the token, for them, you will give an access to that soft copy so that they can read through it. So the various use cases are available for non-fungible tokens. Anything you can convert into tokens and sell it off. Okay, that's what. Yeah, so this is all about blockchain, students. If you have any doubts, please feel to ask. I know that I already passed by 45 minutes for today. It's quite long. I'm really sorry, but I want to make sure that at least you got the conceptual understanding of these technologies. When you're reading, you will be able to follow it up. So as we already overshot, I could able to spend a few more minutes. If you have any doubts, let's take up, or else we can quickly wind up the session for the today. So feel free to drop any questions on the chat box for next few minutes. If not, you can, anyway, you have an option to send all your queries to eisintern@ici.in. Any examination related questions or the pattern or how to prepare, all those stuff, feel free to drop on EIS Inter. The Board of Studies team will help you to resolve your queries. Students, if you don't have any doubts, just let me know. I will just want to show one previous examination paper to understand any of the questions from this chapter. Let's quickly see one paper I would like to show so that you will understand how the questions will come. This is not from chapter 4. Yeah, if you see, students, hope you are able to see it. This is in recent examination question. Briefly explain the advantages of business policy, bring your own design. You remember? Happy employees, faster adoption to technologies, lower IT budgets. So these are all the lower IT budgets, IT support requirement, increased employee efficiency. So there is a straightforward question on this emerging technologies for 4 marks. Now let me quickly see any other question on this. No, 5th question, CBS. Yeah. One more question here. What is mobile computing? Explain the key components of mobile computing. You remember that 1, 2, 3, 4. Okay. So mobile computing, and describe any 4 characteristics of IAS. So 4 plus 8 marks you got straight away questions. Mobile communication hardware components. So what are all the instances of, means the characteristics of IAS. So these are all these straightforward questions. If you see, all the 8 marks came from that emerging technologies from chapter number 4. That's what I'm saying. Those emerging technologies, those 10 or 11 technologies are very important from the examination point of view. So give high attention to those topics. Mansa, DeFi, decentralized finance. Yes, it's also a product of blockchain where again, it's I believe being a chartered accountant, we can be part of that space, especially in the blockchain. Even I'm currently exploring that part. So I would, yes. Harshita, what do you mean by you couldn't able to open the site for queries? Which queries you're talking about, Harshita? So hope you have seen the previous examination questions, students. So those are straightforward. So all you need to do is prepare on emerging technologies, give more focus compared to other things, so that you'll get definitely good marks. Okay, fine, students. Let me know if there are any doubts. I would like to wind up the session for today. So as I said, feel free to drop all your queries to eisinteract@ica.in, and also please share your feedback. So I know that I have taken a lot of time for today, as this is the last class. I would like to complete all the concepts at least. So examination questions, you are feel free to read through it. Thank you so much, students. As I don't see any other questions, I would like to wind up the session. Thank you so much for attending all my sessions. I hope you enjoyed and definitely had a takeaways. Enjoy the rest of the sessions conducted by the Board of Studies. Thank you so much. Thanks for the participation. Concluded, Ramji.